Yo, welcome. Yeah, so what Toby was saying, we're gonna let Bennett take it away here. I got the presentation up. I'm gonna start the stream and we'll just get into it. The presentation is up. So, Robert, if you click on my name where it says live, if you click on that, another little window will pop up to click on like a view stream or whatever. Click on that and then you'll join as a viewer and you can see the um what I'm showing so we can go over the slides together so you can see it.
Okay, I clicked on Allen, and now I guess this is it. Watch stream. All right.
Cool. All right. All right. So let's see here. First order of business, dude. Let's get into. Let's see. So for stellar aberration, you actually had a slide missing uh on your end. So we should do the stellar aberration explanation real quick, if you don't mind. Starting off there.
Okay, you said the slide was missing.
Yeah,
Uh,
you just had this stellar aberration slide, and then there was a slide to give like the follow up explanation because this one is just for the heliocentric, version, and then the next slide was the Kepler's law, and it doesn't. There was no follow up to the stellar ab.
yeah. Well,
You go-
the only slide I have is the one that you're showing, and
oh, oh,
I think I described that by saying the in the upper left you have the need to tilt the telescope, no matter where you are on Earth. You never look at a star directly. It turns out you always have to tilt the telescope at some angle between 0 and 5 degrees, some small angle. And the diagram in the center shows that when you have a telescope at different latitudes, you get different patterns in the telescope. Along the equator, you get straight lines. At the poles, you get a perfect circle, and you get an ellipse in between. The important point is that uh, very to popular knowledge, you never see a star when you look directly at it. What you see is a distortion or an aberration, which has always been a mystery to astronomers. Why can't they see a star by looking straight at it? And why does it move during the year in either circles or lines, depending on where it is? Uh, the other part of that diagram shows the mainstream interpretation why stellar aberration occurs. They say that every 6 months the Earth changes its position relative to the Sun. It's on the opposite diameter after 6 months. And as the diagram shows, if you point the uh, telescope an angle instead of directly at the star at, let's say, January, in June you'll have to point it in the opposite angle 6 months later. So that's their explanation of why the telescope has to be corrected. Why stellar aberration? Now, what we showed in the slides that follow is that Airy's failure shows that number one, the Earth is at rest. Number two, that the ether is moving, and that is blowing basically the starlight as it comes from the star and bends it so that it goes into the telescope. And this happens for every star in the sky. So ether is everywhere in the sky, and it happens to every telescope. So it's a universal effect, and it's all explained by an ether that's out there in space, and it's moving because it bends the starlight. And we have many other proofs for this, but this is just one of them.
So this is why the heliocentrists like Kosho say that the same bending of light is actually a sign of the Earth orbital velocity. That's why they get that confused.
Yeah, they're saying that what you saw in that, yeah, what you saw in the right-hand side there, their explanation is the only explanation for the aberration. But
Nice.
Airy's failure showed not only that there is another explanation, it's the only explanation. Airy's failure shows that you must have an Earth at rest and you must have an ether moving between the Earth and the stars in order to correctly predict the result. So why hasn't mainstream um, changed their minds? Well, once you adopt a position, it's very hard to claim or to admit, I should say, that you've been wrong. So there's probably other reasons too, but once they decided that there's no ether, they couldn't accept Airy's failure. In fact, look at the name they give it. Airy's failure was not a failure. It was a tremendous success because it shows geocentrism and it shows not only ether, but a moving ether.
There we go, Alan. Nice. I was glad to see you guys get started early, and Dr. Bennett, I'm glad that you're here in the first place. I don't even get to introduce myself, but I'm psyched to talk to you, and I'm psyched that you take an interest in all of our discussions and our position.
Well, I'm glad to meet you.
Welcome,
Um,
welcome.
so, were there questions about uh, stellar aberration? Because I don't have, Alan, anything after stellar
Oh no, that
aberration.
no, that was it. I just remembered in the first presentation when we got to this slide, it seemed like you had like a secondary follow up because you were like you went through like the steel man of what the globe says, and then you were like, okay, and then I'm going to explain it for the ether side, and then there was no slide, and you were like, oh, well, we'll just cover it when we do the next one. So I just didn't know if there was more or less information or whatever, but no, I think that adequately answered it. So one more thing that I would add on to that for Shane about the heliosexuals and what they say about the aberration too. So they actually ratio the speed of light against this angle that it produces because it only produces, I think it's like 20 arc seconds, no matter where you're at in the on the Earth. It'll produce this, an ellipse that's 20 arc seconds, or a circle that's 20 arc seconds, or a line. And they ratio that 20 arc second line against the speed of light, and they get roughly 30 kilometers a second. So they're like, "Oh my god, boys, we're in. We did it!" Like, so that's like they're, you know, they
What
just
do you
ratio
mean?
it against the angle.
What do
That's
you mean?
interesting, Alan. I didn't know that. I
Yeah,
didn't know
yeah,
they made
that's
that claim. No.
yeah. Yeah. So what I tell them is I just say if you plot that against the sun and say the sun's moving and the Earth's stationary, it's the same. And the ratio being 30 kilometers is like the only globular coincidence that they have, right? Or one of the
Hmm.
only. So very cool. So, but yeah, that's their big claim is they'll hit you with that ratio, and you just got to be ready for that for the few people that know about the ratio situation because that's
Yeah,
the
I didn't know about that, but now I feel adequately prepared.
yeah. Now you just shove it right back in their face.
As usual.
So, yeah, as usual, right? It just turns out you just have to figure things out. So we got Kepler's law here. So this was awesome. This is one of my new favorite arguments is explaining how you can reverse engineer the mass of the secondary thing that you're trying to account for and act like everything, that you're,
Act like it's pivotal to the equation. Like we need that.
yeah,
Yeah.
yeah, act like it's a pivotal prediction to the model and all that stuff. So I don't know if you just wanted to run down that again real quick about how the mass
Well,
cancels out for the equation. So it's literally just a kinematic equation based on
hey,
two
Alan.
constants and the porosity of the event. What's up,
Yeah,
Invisible?
that brings up the question that I've always been asking about the similarity between Newton's law and Coulomb's law,
Hmm.
where you actually made the stars and planets electrostatic condensates or electricity, that you could apply Coulomb's law and it would actually replace the masses and Newton's law and everything would work, right?
I
Well,
mean,
the planets would have to be charged in order to apply Coulomb's law. You'd have to prove that they're charged.
I think he's
Well,
just commenting on
you
the
also
general formulaic like the comparison, like because the equation is like m1 over m2 over k2, and it's kind of the same formulaic derivation, but it's just an inverse relationship to mass.
yeah,
And this is
that's
like
Yeah,
neglecting the mass entirely, which is funny.
that's
yeah.
what I
So
was.
very similar. So like, yeah, as long as you know the one event and you got your constant, so it'll just scale to the porosity of the event. So,
Yeah,
but
you
yeah, like it
also have
was.
to prove that those things in the sky have masses too, and we don't know that they have masses. So it's
Right.
one or the
Turns
other.
out, turns out mass doesn't matter, right? It's so you can just remove it from the equation entirely. That's what we're talking about. So
Yeah.
So it's pretty
So
interesting.
yeah, as long as you got your constants to establish it, you can do that. So it's very cool.
that's nifty. Yeah,
So
I love that.
yeah,
Do you know
yeah.
why both laws are inverse square laws?
No, why?
Well, if you use Maxwell's law and you use what is called Gauss's law, you integrate the electric or magnetic field around a circle, or actually any closed surface. The surface of a sphere is 4 pi r squared. So you have to divide by 4 pi r squared to average it over the surface of the container that's surrounding either the electric or the magnetic field. And the same goes for gravity. If you have a source of gravity m, and you want to know what is the distribution of that in space, then you have to divide by 4 pi r squared again, which gives you the constant mass over 4 pi r squared. And then you have to fiddle with the constants depending on what system you're in. That's why Coulomb's law and Newton's law have that 1 over r squared because of the properties of the sphere.
Hmm.
Yeah, I didn't know that.
Now I'm trying to see if that's like a sinister upturn or by necessity. Like, why are they incorporating spherical uh, tendencies and attributes
Well,
erroneously?
well,
Well,
it's for the
it's
distribution
math.
of the sphere. Yeah, it's a distribution of the
It's
field. It's a
math.
sphere, so they have to, right? So
So it is. Yeah, it's just math.
yeah.
Yeah.
All
I mean,
right.
I hope you guys
So
believe in a globe in math that is a
yeah,
sphere.
I'm not afraid of a
no, no,
mathematical
no.
globe. No, that's totally fine.
Feasible on paper.
Well, you also have those applications of a Gaussian hemisphere too, and I put those in the chat. So those are
Yeah.
pretty interesting.
I mean, no, it definitely has its practical applications in sphericity mathematically or mathemagically, however you want to think about it, for sure.
Yeah, because you got to think they're trying to describe an omnidirectional source of attraction, right? So it's
Oh
gonna
yeah.
they're gonna
I
sphere
mean,
out of their minds with it. So
we
it's
can't do the sky on flat Earth without sphericity, right? Without at least a half globe to Diazimuth the grid of vision. So
a little semi globe,
right.
a semi globularist. I'm only a half globularist.
Yeah, and if the dome is a Gaussian surface, well, you have your charge distribution right there.
Yeah, I mean that would explain the equipotential distribution, right? So if it was curved, there would be like the fall off points would be different. So that's an interesting thing. We'll have to show Bennett that later and see what he thinks about it. The corona motor thing with the
Oh, the
Alan,
atmospheric.
yeah.
Alan, could you put the Kepler's law back?
Yes. Kepler's law.
In the upper left, at the beginning, you mentioned that the m's cancel out.
Mhm.
Now,
Oh,
whenever
the
that
little
happens,
M's. Yeah.
yeah, the little m, right?
Mhm.
Actually, the GM, capital GM that you see in the numerator, that can be considered to be just another constant, right? G times m is just another constant.
Right.
And if you use Newton's law, you can derive Kepler's law. But the m's cancel out, which means it doesn't depend on the characteristics of what you're measuring. In other words, Kepler found this just by looking at the stars, right? Or the planets, and keeping a record of how far they were from the sun and how long they took to go around the sun, R and T. And he plotted this graph that's shown, and he discovered what is called Kepler's law. He had no idea how this was proven. This was an empirical law, and this is an example of kinematics. He didn't apply any law. He discovered the law by making measurements. So this is kinematics. Newton, however, said if I use the law of gravity, which is little m big M g over r squared, I can predict the motion of the planets. And he did. And that's why the m's cancel out, because this is not only a dynamic law that is proven by Newton's laws, it's also kinematic in the sense that it can be discovered just by measuring the motion of the planets, how far they are from the sun, and how long it takes them to go around the sun. You don't measure the mass or any other characteristics. You just follow the dot of light in the sky and keep a record of its measurements. I think this is a good example for you guys of the difference between kinematics and dynamics. Sometimes they're the same. In this case, Newton's law predicts the same as Kepler. But Kepler didn't find it by using a law, he did it by measuring. Newton found it by applying a law and then discovering it. See the difference?
So you're saying Kepler proposed it based on an optic measurement, though, and then
Yeah,
Newton predicted it dynamically. Is that what you're saying? Instead of just knowing like the
yeah.
pattern so backwards engineering the observation from Kepler, wouldn't that be the same way then to predict? To predict like with Newton's law is just well, if I backwards engineer the pattern with Kepler, wouldn't I be able to do the same thing?
Yeah, well, Kepler used just observations, right, to
Right.
to discover this pattern. But what I'm saying is Newton said, all right, let me apply the law of gravity to the motion that I see, the r and the t. And what you see in the upper left is the derivation of Kepler's law from Newton's laws, right? And as you pointed out, the little m cancels out because this is something that could have been discovered experimentally, and it was Kepler discovered it.
So that explains how they get the so-called masses to the things in the sky, is they back engineer the equations and just basically insert any number that fits the equation. So it's kind of like relative, basically.
Yeah, they
It's kind of like
applied Newton's laws and said, okay, I know that it applies to the Earth and the sun. Let's apply it to the other planets. And yeah, they used Newton's law basically, and Kepler's law and other laws to decide what the little m is in the equation. Big M, of course, is always the sun.
so this is how they can move the distances to the sun, and the equation still turns out the same.
Well, that's just scaling covariance, right? When they have a dynamic system like that, they can change the parameters and we'll move the model all the way through. Nothing changes. That's part of the system. That's how they fool everyone. Part of it, partly.
Yeah. I think it was like step one, get the mass of the sun, and then use that as the focal point to measure everything else to get its mass. And then you could start individually taking the periodicity of like the moon orbits for each one of these things. Like now Jupiter has like 3,800 moons or whatever. And you just like start applying that, and you can it'll just fit into everything once you already have that established within the framework.
It's funny because isn't that how they built the solar system, right? They couldn't figure out the three-body problem, so they built a separate series of two-body problems, literally like planets and the sun, right? So Earth and the sun, Mercury and the sun, Mars and the sun,
Mhm.
and they planted those orbits, and then they added them all together and went, look, behold, a repetitive kinematic equivalence, but actually we have no dynamics because we have no idea how any of the systems work together. But
Yeah.
individually, they totally work mathematically, and it's fine.
Yeah, you put them together and it doesn't work at all. But hey, here it is.
Yeah.
Well,
All right.
it works with Æther, and that's what's important.
Yay.
It's the Æther that's rotating around the sun that explains the planetary motions, and the motion of the moon and the Earth around the no. The motion of the moon and the sun around the Earth is another set of ether winds that determine the period and the distance
I have a
of
quick
the sun and the
question.
moon from the Earth.
Couldn't you interchange the sun with Polaris and it would work exactly the same since everything moves around Polaris?
Well, that's hard to say. We're not even sure that Polaris is a star. This goes back to when
Oh,
I gave the slides. I pointed out that the lights that we
Oh
see
yeah.
in our telescope
So
presumed to be.
Polaris actually could be a vortex point in a toroidal field then.
Yo, hold on a second, Invisible. Listen to this spectral reading thing. I forgot to ask you about this. Go on about, or please continue.
Yeah, Polaris and the other stars are lights in the sky, right? So mainstream says, well, they're all suns, or in case of galaxies, they're thousands or millions of suns, star systems. Well, that itself is an assumption that's never been proven, and it probably never can be proven. The light you see in a telescope is not the same as the light that comes from the sun, at least not exactly. It has they have different spectral characteristics. And from that uh, small small bit of information, the spectrum of light that's in starlight, they make wild predictions about how old the star is, what it contains, and so on.
I mean, with stellar spectroscopy and such.
Yeah, astrophysics. Astrophysics, what I'm saying is based on some wild assumptions that the universe that we see in the sky is the same as the solar system that we see here. There's been no proof of that. And according to the scientific method, what is the rule? You got to make measurements. How do you make measurements? When you're at the star system and you can observe it. You can't observe the star system just by looking at light that comes from it and making judgments about how many planets it has and what it contains. That all may be true or it all may be false. According to the scientific method, it's unproven and it could be unfalsifiable too,
Hey.
because the sun is the only representative we have of what could be a star. I'm casting doubt on some of the claims that are made about um, astronomical observations.
Yeah, that's an admirable position. I think doubt is definitely warranted.
And I'm not saying that I'm right or wrong. I'm just saying scientific method requires that you have more upfront evidence, such as being at the location of the star. And as I said, that's probably not ever going to be possible.
So what do you think Polaris is then, really? And then do you think it has any significance as like the focal of the rotation point for us, that beyond anything the normal heliocentric position would have, or what?
Well, based uh, on theology, on revelation, if we ask what are the lights in the sky, the Bible says the stars are uh, oh they have the breath of life in them. That's one of the quotes. And what's another one? The angels. Well, anyway, the interpretation is that the lights in the sky can be symbols that represent a different material or immaterial realm, a realm in which there are beings without any material substance. In other words, angels. And I,
Hmm.
I talked about Hildegard, if you recall, in the slides. And Hildegard gave a revelation, some visions that she had back 8 centuries in Germany. that the light from the sky is actually controlling the motions of the planets in the solar system and all the other objects too. And this is the concept of an ether wind, which is, to my surprise, revealed 8 centuries ago in the writings of this German scientist.
Wait, so the ether has
So what? Yes, go ahead.
astrological aspirations too, as well?
No, not astrology. Okay, I'm not saying anything about the position of the stars affects our life on Earth. What I'm saying is the source of the changes that occur in the solar system are described in this book. It's somewhere on the slides. It describes the motion of the planets under the influence of ether winds, and the ether winds are being uh, uh, sourced, are being produced by a set of 16 stars that are fixed in the sky. Now, this sounds pretty wild, but the question is, can you unprove it? Can you prove that it is false?
What's the
And
book you're
the answer
referring to,
is
by the way?
no. The book is called. Let me look it up.
It sounds like a book we're gonna have to PDF and distribute to everyone en masse.
And it's
On it,
slide
on it.
45, Hildegard Cosmology. And you can get it at the colbycenter.org, or maybe it's only $10, I think.
I do love that
It's
they
a
describe the ether wind moves the planets, or as we call them, the wandering stars. That seems evident
yeah.
and corroborative. I like that.
But what you have is some in mainstream they would totally laugh at a concept which says that the solar system motions are like a giant cosmic video game, right? Where winds from the stars are influencing the motion of the planets and the sun and the moon, not the earth, of course. The earth is fixed. And this is this is an object of ridicule, because the first time you hear it, you say, well, how can this be? Well, the answer is, if it is not impossible, it's possible. Heard of realism a lot philosophically? What realism says is, if something is not impossible, it's possible. Right? So you can't dismiss something just because I've never seen it, I never thought of it, or it doesn't sound right to me. What you have to do is disprove that it can't be true. And that hasn't been done.
It'd be interesting
Yeah,
to
that's
hear
it.
what you think about astrology and how seriously you take that, given what you just said, and how the ether wind or ether effects might be part of the science of that. I mean, you've heard the idea that billionaires follow astrology and millionaires follow astronomy.
And followed alchemy much more than he followed physics. Did you know that? He was constantly trying to
I have heard
change
that.
lead into yeah, he tried to turn lead into gold and try to make many other changes, and he spent more time doing that than he did doing physics. And yet, look what he did in physics. Probably the greatest mind of the last 4 centuries in science. To answer your question, astrology, what do I think of it? I think I indicated astrology to me is saying that the motion of the planets, the stars, has an influence on life on Earth. In particular, on particular people are influenced by the location or the motion of the stars and the the phase of the moon, and so on. So the configuration of the sky somehow influences the Earth, and that's not what I'm saying.
Oh.
What I'm saying is, I'm sorry. What I'm saying is that the revelation that was given to this to Hildegard 8 centuries ago, which has been verified by the Catholic Church. The local bishop has to approve it, but even then, you don't have to believe it. You can take it or leave it. But I decided, okay, when my friend said, read this book, it's got some great stuff in it. That friend, by the way, was Bob Singenis. And when I looked at it, I said, okay, there's some strange things being said here. It's very simple. As soon as I find something that's false, that I know to be false, then I can throw this away. Well, that was 10 years ago, and I still haven't found anything that I can find that's in that book that I can prove is wrong. And so, according to the scientific method, I can continue to believe it until I'm proven wrong. All right, so that's the difference. I don't believe in astrology. I believe in what I just described. That there is an influence using ether by the angels, who are basically the stars, and they're the ones who influence the motion of the solar system.
So
I'm
would
not
you
saying that. I'm
would
not saying they influence our life. In other words, they don't decide whether we're going to have a good day or a bad day. Okay, they have nothing to do with that. Ether doesn't affect a person physically. It affects the motion of the planets. That's it.
would you believe that the stars are more local then? Closer?
Yes, but
Excellent.
that's a different reason. I don't believe the redshift is a Doppler shift. Okay? The
What
reason
do
that
you? Yeah, what's your explanation for the
the
for the
reason
shift?
yeah, the reason for the redshift is believed to be the Doppler shift, and that goes back to Hubble in 1927 when he discovered the redshifts, and the interpretation that was given to them to the world of science then was that it's the Doppler shift that's causing this. So all of the stars that have redshift are receding from us, and this disagreed with the Big Bang, right? Which says that everything is expanding since that time 13.8 billion years ago when uh, the source of the Big Bang exploded or expanded. They like to say, not exploded, expanded to into what became the creation of the universe from nothing. By the way, creation from nothing.
Yeah,
Um,
the old from nothing came everything story, the classic.
Once upon a time, there was nothing. And then all of a sudden, there was everything. No one and nothing caused this. Don't worry about it.
you know what Aristotle said: "From nothing comes nothing," and that's been true since he said it. Whenever they claim anything is caused by nothing, well, nothing comes from nothing. Nothing is nothing.
Yeah, nothing in, nothing out.
Yep.
Another good one.
Uh,
So that book we're gonna have to get and put in our library. I think I'm gonna have to read that probably. Take a look at that. I
you can
like
get a
the.
PDF version, and that's probably better because you can copy all the diagrams, which is
Oh
what I
yeah,
did. A lot of my slides were taken from that book.
nice. Yeah, I'm sure we'll have a PDF before this is even done. To be honest.
It's worth it.
I
Even
like
if
the
you
five
reject
elements.
it, you know what it is.
So that's like, so it's just like the on the right, the five spheres is like similar to the five elements, which is actually the first time I ever heard of ether was on the Space Buster channel way back when they were trying to talk about energy and free energy and they named it as one of the elements. So everyone who does that pulls it from this ancient cosmology, probably. Then, like that comparison of the 5 elements, including ether, probably comes from Hildegard. Then, right?
No, it probably comes from Aristotle, or at least the ancient Greeks. They called the ether the quintessence, the fifth essence. Okay, and it was supposed to be the stuff that the stars moved in, which is pretty good.
Accurate. Yeah.
It's also what everything is made of. So everything is ether, not just the stuff between matter, but matter itself is made of ether in a bound form. Okay, we have rotating models of ether. It could be a globe, it could be a torus, it could be many different shapes, but an internal rotation of the ether can cause it to be stable and to have the properties that we call mass, that is resistance to motion. And that all fits in with what we know about ether. What I would recommend to this group is to try and do research in Russian literature. I got to thank Alan for getting the English translation of Vatsukatsky's book. I've been trying to read it in Russian, and I gave up. So now I have to try and plow through hundreds of pages. Of course, he's dead now, so you can't even communicate. But you have to try and understand what he wrote. You have to realize that the West isn't going to do any ether research.
We do.
There's a tight lid.
We're well aware.
Yeah, I guess there's a tight lid on anyone who brings up the subject. So,
Hey, Robert,
I would
why do you think that is? I'm just curious.
Well, it's sort of intellectual pride, right? That they have this nice, cozy system where they control all of the scientific information through the textbooks, through the internet, through the videos that they publish, through all of the science propaganda. I'm not saying it's all propaganda. There's plenty of dissidents out there, except if you compare the dissident voice against the mainstream voice, it's totally out of proportion.
I agree.
So why is this the situation? I don't think enough people understand how to find truth. A branch of philosophy is called epistemology. It means the search for the truth or the study of truth. And the scientific method is one of the approaches, but you also have to use logic. You have to understand the interpretation of what you measure. And once they seem to make the wrong turn in the path to truth, they seem by inertia to want to stay on that path and to object to anything that says, okay, I got to study this new thing and see if it's true. Rather than that, they'd rather just dismiss it, ignore it, ridicule it, whatever. And that's been the story for a long time.
But you know better than most the significance that Einstein played in his trying to hide and obfuscate, and then the way that they propped him up and discredited, objectors, and there was no everyone got the treatment where if you wanted to debate him, you're an anti-Semite and nothing that can be questioned. But so his foundational role in moving this forward and propagating it throughout, you don't think that's suspicious as well?
Oh yeah,
absolutely,
definitely. If you look at Einstein's writings, you will find so many contradictions, either in the same document, a couple years later when he gives a talk somewhere, and he contradicts what he said in his book.
Yeah, but
like one examples I can give them, but maybe you guys know the
right.
example.
But But I'm saying, don't you think it was a behalf, like a conscious decision on behalf of the establishment and or the mainstream scientific community to obfuscate the truth, to move away from truth, and to leave everyone with Einstein's musings as mathematical nonsense garb to wade through to occupy your time?
Yeah, absolutely.
Do I think it was a conspiracy? No. Did they get together in some dark cellar, smoking cigars, and decide, okay, we're going to support Einstein. We're going to do this. We're going to do that. No. However, there is what is known as a wink and a nod conspiracy. In other words, if you're in a room with somebody and you agree with them, you can just look at them and like blink your eye or give some kind of body language that you agree with them. All right. Plus the publishing, as I said, of all these mainstream documents, all of the textbooks in schools that all support Einstein or mainstream thought, and they have control. There's no doubt about that, and the truth will get out eventually, but I don't know. God knows when.
Well, they don't have control by accident, right? They're not doing a kindness. To me, they're selectively steering knowledge, culture, and information in a direction that they want it to go, which probably decidedly is not in the best interest of us.
Wouldn't you like to have all the money that was plowed into NASA for the space shot, or all the money, all the
85
money that was
million
plowed?
a. Oh boy, what could we
Yeah,
do with that money?
yeah.
Oof.
Or all the
Yeah.
money that was plowed into CERN, the big lab in Europe, big physical particle physics lab, and they want to build a $3 billion lab.
Yeah, we're very
Why?
concerned with the money that NASA gets. We're trying to do
Hey,
stuff about that.
hey, Robert, did you know that there's 30,000 active in use particle accelerators in the world? Not just CERN.
Certainly not the same size.
Not the same size, but isn't that nuts? I think that's nuts. I just found that out. That's
Well, a
crazy.
particle accelerator could be, something on your desktop. Low speed, but all you need is a magnetic field to cause the particles to rotate. You could
Ah,
call it an accelerator.
so
But
they just
yeah, that's a
call it
big
that just to kind of like increase the. Okay, I see what you're saying.
yeah.
Oh,
Oh, 33,000 is a big number.
That's true.
Yeah.
Yeah. Well, yeah, no, all the money they give to NASA. So, what do you think? Do you think they're making scientific progress with all these colliders, jamming particles that may or may not exist together?
Well, I think if you look at the videos of Sabine Hassenfelder or uh, Sander Unziger, if you look them up on YouTube, those are two particle physicists who have been cast out, let's say, from mainstream. They've been they either quit or were fired, and they know the inside. They know what goes on. So I would either look at those videos. They both have written books about their experience, and so those two I would recommend for an inside view of particle physics.
yeah. What's the names again? I'm
Yeah.
definitely gonna look
Hold
into that.
on. One more
I
time.
got, yeah, I got you, dog.
Okay, Sab- Sabine, Sabine,
SAIEN.
Hassenfelder. If you do a search for Sabine, it's not a common name, so you'll find it
Right.
on YouTube. And the
Sabine,
other
and
one
then
was Alexander
Alexander
Unziger,
Unziger.
Unzicker.
Oh, right there. Okay. Shane posted it. Thank you, Shane. Awesome.
We found it. We're good.
Now, my background is not particle physics, so I can't really go into depth
No.
about
You mean
that.
pseudoscience?
Yeah,
You know,
yeah.
it's quite.
They
Oh,
get
go ahead.
incredible money, and of course, they're looking for particles that they don't even know if they exist.
Right.
They're
And they're
willing to spend.
jamming these particles that may or may not exist together for repeated reasons.
That's what I was gonna say. How do they isolate a particle? You know, like, or do they send clumps, or like what's? It just doesn't make sense to me.
Are they counting particles that they know don't exist, like
Oh.
virtual photons? And
Yeah.
not for real.
No, I believe you. It's just
No, it's true.
ridiculous.
Yeah, it's absurd when you say it out loud.
I'm still looking for the Shane particle, and I have Sigma 5 confidence that we'll find it with enough funding. So
Wow.
my checkbook is available for you to deposit all of your checks into. So
You will need a
just give me
Shane particle detector, which I own the exclusive rights to. So
We don't even need the
Yes.
NASA funding, man. Let's just get a fraction of the dark matter funding. That's like one of the major things being funded right now, this dark matter research.
You know what's crazy?
Dude.
So I live in Vegas, right? One of my friends, he used to work at Desert Research Institute, right next to the Atomic Testing Museum, and there's a particle accelerator right underneath it. Like, it's right underneath Vegas. And he showed me a picture of what was claimed to be dark matter, essentially. He had this like crazy encrypted phone. It was like one of those TZX, whatever.
was it just a picture of nothing, and he was like gagging you, or what?
No, it was just it just was like this little red like light. That could have been bullshit, but I just didn't know that there was a
What?
fucking accelerator underneath.
Dark matter. We found it. There it is, boys.
I
Look.
did. I just
Boom.
found it.
Let me see.
I
Where
just
is
found
it?
it.
Where is it?
It's right there.
Evidence
I didn't know
in
it was
science.
square.
Yeah. Yeah.
Turns out
Someone
we can
showed you a
mathematically
light
make it
project.
spherical if you prefer.
Someone showed you a light and told you it was dark matter. I missed what were you saying? What is your take on redshift? Because I'm trying to figure out what I think redshift is. Like, what do you think the cause is?
Redshift. Yeah, this was on the slides. The emission of ether from stars, besides light, cause the speed of the light to be boosted, and that would appear to us on Earth as a redshift, because the speed of light would be increased, and therefore the wavelength would be longer. So Doppler shift is the conventional description or the belief of a mainstream that we have a vision of stars that are receding because they're Doppler shifted. Now, if I'm correct, and I'm basing this partly on Hildegard's ether wind model, if I'm correct, then the stars can be stationary, and if they emit ether along with the light, then it'll have the same effect mathematically as a redshift. And the wavelength will also increase with incoming ether, an incoming ether stream with a light beam riding on it. And that's my model so far, Austin, of what a redshift really is. And that would mean we have a static universe in the sense that the stars are fixed distances from us and not receding at more than light speed, which is another fantastic contradictory concept. We have redshifts up to I think 7 or 8, which means 8 times the speed of light. So
Right.
that seems to present no problem to them.
Oh, they don't even blink.
It's so ridiculous.
Yeah.
Yeah, that's crazy. They say that because space is not information, right? So it can do whatever it wants. But okay, that's interesting. And so static, of course, in the sense that in the terms of distance, right? Like the distance to the stars are changing. Yeah. Okay, that's very interesting.
They're rotating. Of course, they're rotating, but they're at a fixed distance, radial distance.
Right.
Right.
Okay, yeah. Interesting. I'm not gonna say that I fully understand what you're saying, to be honest. Like I think I understand it partially, but I'll have to try to wrap my mind around it. Because like I'm sure you've heard of things like the idea of tired light, or I don't know if you've spoken to Alan about the idea of like electromagnetic retardation causing red and blue shift.
Yeah, that's where I was gonna go.
Yeah, so like right now, I don't know at all what redshift is, but right now I think it may have to do with the overall torus field geometry, and we're looking out at the field diverging away from us, right? And so we would get some blue shift closer to us because you're going to be near the central part of the vortex or the convergence portion of the field. And then as you get out of that immediate central point, then you're going to predominantly just see the divergence as it diverges away from the center and then loops back around. But I don't know. I mean, see, that makes sense from my perspective of a plane of observation. So we only see the top half of the field. So we wouldn't see the blue shift looping back towards us because it would be underneath us. But I'm interested in your idea as well. You said that the stars are emitting ether.
And my model, as I said, is what was on the screen before, the Hildegard book.
Right.
And that describes 16 stars that are fixed in the heavens, and they have ether jets or ether winds, ether streams, whatever you want to call it, that are aimed at the solar system. And what they produce is a reduction in the speed of the orbits. So if you look at the sun compared to the stars, you know that it's 4 minutes behind the stars every day, and the moon even more. So if we ask, what is the rotation of the universe? The answer is, well, every star, every galaxy rotates every stellar day. However, inside the solar system, we have different rotations. And this book explains the difference as the effect of the ether winds, which are coming from the heavens, from the background stars, and they cause the it's called a counter current, a counter motion to the motion of the stars.
Yeah, just like we have in the atmosphere, right? Yeah, like the jet streams will go in the counter rotation the higher you go, right?
So
Yeah.
I got a quick question.
That's actually a pretty beautiful idea. So there are stars out further away, as you call them, background stars, that are effectively guiding what we call planets. Shingud?
Right.
Yeah.
So
According to the Hildegard model, there are primary winds. Those are the ones that slow down the sun and the moon. Then there are secondary winds, which slow down the planets. And there are third level or tertiary winds, which slow down the moons. Well, that accounts for everything in the solar system.
Right.
It's a wild idea.
I like it.
It was revealed, as I said in the book, 8 centuries ago. And like I said, 10 years ago, I was given the book and I said, I'm going to throw this away as soon as I find something false. Well, I never found anything false. I found there's some wild ideas in there. But here's another one. You were told that the planetary orbits are ellipses, right? Kepler's law?
Yep. Mm-hmm.
Right?
Yep.
Okay. Hildegard says, no, all of the planetary circles, orbits are circles, which is actually the same as the ancient Greeks thought. Aristotle thought all of the it's in the heavens were circles. So how do we explain that mainstream tells us that we have planetary elliptical orbits? Well, these ether winds can speed up the orbit in places where there should what we would be interpreting as a perigee. That is a closest approach. And it can slow down the circular motion at the opposite side of the orbit, which is the aphelion or the apogee. So when you make measurement, here's the crucial idea. When astronomers make measurements of an ellipse, do they measure the radius or the speed? You know,
I don't.
they measure the speed. The speed is obvious in a
Yeah, I was gonna
telescope.
say radii, but then the fact you asked made me think that's obviously not the answer.
Well,
Okay.
well, if you see a planet in the sky, how do you know how far it is?
Oh, that's a great
You
question.
don't.
Yeah.
You don't. Can you tell how fast it's going? Yes, right? At least
Yeah.
in arc seconds, right?
Yeah, exactly. Yeah.
So, okay, so they don't really measure the radius. So they really can't tell you, well, this is an ellipse because in part of the orbit it's bigger than in other places. No, they can't tell you that from direct measurement of the radius. What they do is infer it by the fact that at certain points in the orbit, the planets speed up. And they say, aha, it must be at perihelion, which means at closest approach.
So that's
And
definitely
okay.
that's
So I'm sure you've never heard of this before, but it's called in mathematics, it's called a direct driven orbit. In other words, there's an external force besides gravity that's causing the motion.
Hmm.
So this is one of the predictions that the orbits of the planets, and if we ever are able to actually measure the radius of their orbits, we should find out that it's constant no matter where they are, that they aren't elliptical. So
So
there's a
Wow.
prediction. There's a prediction that can be tested.
that's super interesting and relevant to what I was trying to think about before when you're talking about ether wind. So, like, if we think about like an ethereal vortex that moves, say, the static stars in one direction and accounts for that c plus v speed in all directions all the time because they're moving. Like, if that's the ether wind, then my next like question, if I'm just trying to like ask a bunch of people who believe all the same stuff that I believe in a room comfortably, what moves the wandering stars? And if all the stars are moving with ether, then how do the wandering stars get pushed in different directions with different velocities over different times? And you happen to come out with one of the coolest answers to that I've ever heard.
Yeah,
And that it's different
bro,
directions from
there's a
the static
synchronicity
stars.
here because what I was about to bring up to you is retrograde, right? And so, like, you obviously have like the Neo-Tychonian model, right, where it's the planets move around the sun as it moves around the Earth or whatever, and that would deliver a kinematic equivalence of the observation of retrograde, right? But like at the same time, like you said, like actually the planets could just slow down. Because what we call retrograde is, of course, looking at them in relation to the background.
Mm-hmm.
So we're like, oh, it's going backward. It looks like it's going backwards, right? Because it's in relation to the background. Because in their model, the speeds must remain constant. So slowing down isn't really an option for them. So, they have a different interpretation. Then the Neo-Tychonian model kind of adopts that approach. But I feel like if you remove that limitation, really, and it's pretty crazy. That's why I'm saying it's a synchronicity, because you're talking about something that would actually slow down the planets, or could, right?
Yes. Yeah. Well, actually causes them to move the way they do. Yeah.
Yeah. Yeah, that's a
Now,
trip. So
as far as retrograde is concerned, we have two things going on. We have the sun hitting the Earth, right? But at the same time, the planets are orbiting the sun. So it's called secondary satellites. The sun and the moon are primary satellites of the Earth, and the planets are secondary satellites of the sun. So you have the combined motion of the planets around the sun as viewed from Earth, which is the primary source of everything. Everything rotates around the Earth.
Right.
So to observe the retrograde, I don't think you need anything more than the circular motion around the sun of the planets combined with the orbiting of the sun around the Earth to explain retrograde motion.
yeah,
I
I'm in
don't think you
complete
need it.
yeah, I completely agree, right? I mean, it's like actually Robert Sanginis, right? He has a very good visualization of that. He actually he'll put the central axis on the sun, show the modern heliocentric model. He'll just move the central axis over to the Earth, and you'll get the same retrograde observation, right? But what I'm saying is, I mean, and yeah, I always bring that up, right? Because my main battle is to show people, oh, you've been duped, and there's a kinematic equivalence in retrograde. Certainly, in no way is showing us that we're flying through space. But like, even if you actually removed that, you could still explain it just by them slowing down. Like if the planets just slowed down, they would look like they're quote unquote going backwards in relation to the background, which is what we actually observe. They just impose like a constancy of their speed or whatever. But like I will say, this is where I really want to read this book. I guess is what I need to do. I'm just so busy, but like the way I currently see it, and I do also apply the scriptures, and that's because they've just proven to so consistently be accurate. So I was looking at early church fathers and stuff, and it says there's seven layers to the firmament. And the way I currently kind of understand the idea, regardless of the number, is that there are different layers for different celestial quote unquote bodies, meaning the sun and moon are in one, the quote unquote planets are in one, the stars are in another. So I don't know, does that resonate with you at all? Or because I did hear you mention the idea that they may be more local in your opinion. So you're not stuck on any of the current claimed distribution of the stars and planets, as in their relative distances.
You mean, do I buy into the mainstream model of the Big Bang and that everything's expanding and
Well, no, not. I know you don't necessarily believe in that, but more so just the layout of them is in and of itself, right? Like, I don't know. There's an overlap here anywhere because the planets would be closer, in my understanding, and the stars would be further away, and that's what kind of everything says. I guess what I'm saying is, are you open to the idea that there is actually separate segments for separate phenomena, and that really what we call planets are just more local stars? Like they're the same phenomena, but they're different, and they may even be sentient, but they're closer? Or does that sound like a stretch to you?
well, if I go back to Genesis, when it speaks about the creation of the stars, it says God created the great light, the sun, the lesser light, the moon, and the stars. Doesn't say anything about the planets.
Exactly.
And of course, the ancients believed that the planets were stars, but they were wanderers. That's where you get the name planet. In Greek, planeo means to wander.
Wander,
And
right?
so they saw these stars that were wandering, and what was it, 7? No, they only knew 5 at that time. And how we get the concept of planet distinguished from stars, from observations, not from revelation. So the planets are kind of oddballs in the biblical context. As far as science is concerned, I was speaking before about how we really don't know what the stars are just by the light that we get from them, because that like you said, it could be tired light, it could be different uh, effects that are caused before the light leaves the source, like an intense gravitational field. If light is emitted from an intense gravitational field, it's redshifted.
So,
Uh,
Robert,
so
interesting. You said right. Oh, I'm sorry.
yeah,
I'm
go
sorry.
ahead.
I thought you were done. No,
No, go ahead.
Well, I was just reading this right here with Genesis 1:14, and God said, "Let there be lights in the firmament of the heaven to divide the day from night, and let them be for signs, and for seasons, and for days and years, and let them be for lights in the firmament of the heaven to give light upon the earth." And it was so. And then he says, "And God made two great lights, the greater light to rule the day, and the lesser light to rule the night. He made the stars also." So it's almost like there's two separate um, things that's being mentioned there, right? Lights in the firmament, and then stars.
No, I think
Yes.
light refers to all of them, though, right? I mean, like the lights in the firmament are being created, and there's a lesser light, a stronger light, sun and moon, and the stars. Those are all lights that are within the firmament. Where like my current understanding is actually that I mean, this is gonna sound crazy to some people, but whatever. I think that those planets are stars. They're closer, and they basically bucked the system. Like they left their appointed places, and now they are basically being kept in place. And that's why the idea that there are background stars kind of sending what you called ether wind to it is interesting to me. But that's what I think. And I don't think we want to talk about what are the stars or what are the planets even. Like, you said, well, we can't really know what the stars are just by seeing the light from them. Well, same goes for the quote unquote planets, right? Because the highest resolution shots of the planets that are enhanced with CGI are significantly different than what people think they look like. So it kind of, then you have to get into the question, well, what is light? And so then you were talking about the idea of like gravitational field affecting the light that we see. Well, it's like the primary questions here, which are still at the cutting edge of physics, right? Like, what is light? What is ether? And then what is gravity? And I think gravity is just an emergent property. Like, I think it's just the effect of oscillations within the ether or the background, which acts like a fluid. I don't think it's anything in and of itself. I think it's one half of the equation, basically. Like there's an equal and opposite reaction to that. And I think everything's electromagnetic, including what we call gravity. And then I think light is an excitation of the background. So I guess long story short, what I'm saying is to try to really understand what a star could be, we wouldn't have to know what light is and what would cause it, right? That's all we have to go off of is just light. I don't know. Like I can't see any intellectual path to distinguishing the stars and the planets unless I just start, just drinking the Kool-Aid of pseudoscience where they just make stuff up because.
Well, I think we all expressed a healthy skepticism of stellar spectroscopy already. I think we all agreed upon that.
Well, yeah, because like, what is light though? Like what is spectral lines?
I'd like to go back to whoever quoted Genesis.
Yeah.
And said the line that said, "Let there be light." The
yeah,
right?
let there be and let there be lights in the firmament of heaven. Genesis 1:14.
Right. Interpretation of that is that is not just the creation of light, because remember before that was darkness.
Right.
So it's the light in the sense that we use it today, but it is also light in the sense of creating life, a life form, which is based on light, which would be the angels. And that's why this is consistent with saying that the light that we see from the stars is actually the symbol or the representation in physical terms of what is actually an immaterial being, an angel. And that's why it makes sense to say that they can generate the ether winds because they have power over the physical world. They can appear, for example, in bodily form. They can perform what we would call miracles. And so my interpretation of Genesis that was read is that the light refers not just to ordinary light, but to the creation of the angels. And then it makes sense to say that later on, oh yeah, then God said, I created the greater light, the lesser light, and the stars.
Right.
Because
That's
then,
so weird.
then that represents all of creation.
Oh wow, that's pretty profound. So you're saying like a distinguishing idea between like the initial lights being the angels and then the subsequent lights being stars. Like
Exactly.
Gotcha.
Right.
I like it.
That's interesting. I never even.
Yeah, what a great answer, man. Like,
That's not mine. It's from reading.
still.
It does make sense here, right? Because as I was reading it, right, and it says, "Let there be lights in the firmament for signs, seasons, and days, and let them be for lights in the firmament, and give light upon the earth." And God made two great lights, right, the sun and the moon, and God set them in the firmament, and to rule over the day and the night, and to divide the light from the darkness. And God saw that it was good. So it says right there in 16, it says he made the stars also.
Right.
Exactly, you're right. Yeah.
It's weird how they just kind of, well, not they,
Distinguish
but
it, yeah.
yeah, it's like right after that. It's like, oh yeah, by the way, he also made the stars.
Yeah, that's very interesting. It's very interesting. Like I will say I don't. Okay, so my mind is kind of starting to melt a bit when I start to think of the idea of like the stars emitting ether or like an ether stream. Is it more so guiding the like harnessing or guiding the ether that is the canvas that's there, or is it as if to imply that there is something outside of the ether per se, right? Because if they're creating, like if they're emitting it, then they're not limited to the ether. Does that make sense? Like I guess I'm not. I'll read the book for sure, but I guess I'm not like it. They're emitting it. What is it, like? Is that what you said?
Yeah, that is the concept that I'm giving. The analog would be, suppose you were riding a boat, a power boat, in a lake, right? And your speed is determined just by the speed of the boat. Now you're going up or down a river. Now you have to add in the speed of whatever it's moving, the water speed beneath you. So consider the water is like the stream of ether, and the beam of light is like the power boat. So you're boosted basically by the ether stream, so that you actually can be moving faster than light. And by the way, Austin, did you know that no one has ever measured the speed of light in space? So we really don't know how fast light moves.
I
It's
did know
only
that
been
actually.
measured. Yeah, yeah. So they make extrapolations that, oh, we measured it in the laboratory and we found it was C. Well, first of all, you did it with a vacuum interferometer, and that means that there is nothing to interact with the light in order to produce a reading. So of course you got C. Like having a bathtub full of water and saying, I'm going to measure the water waves, but because the water may be dirty, I'm going to drain the tub before I measure the waves in the tub.
All right.
Well, are you surprised when you get 0 waves? I don't think so. So if you pump out all the matter and only have a vacuum, then light has nothing to interact with in order to produce a reading.
Exactly. Yeah.
So
Question for you, Robert.
anyway,
Now, based on your concept of the stars basically emitting ether, I'm kind of with Whitsitt on this one, trying to wrap my head around it. Would you say that there's different, let's say, parts of the celestial sphere, depending on like where you are on Earth, where there's different types of emission, I guess, from different stars? I'm trying to wrap my
Well, he
head
did give
around
a good analogy. You heard his analogy, right? Like you're in a body of water. Like the stream would be the ether,
right.
like the ether
Like a
stream, and
jet
then you're the
stream.
boat within. Yeah.
Yeah. So like a jet stream for a plane kind of thing, right?
Sure. Yeah.
yeah.
Okay. Gotcha.
And that does match what we see on the Earth too, right? I mean, that's what we're seeing with the ether drift measurements.
Right.
So the principle does seem to be pretty tried and true. I guess. Yeah, so basically they would be creating some type of force within the ether, directed internally to either speed up or slow down the planets and guide them. Does that sound right?
Well, let's go back to the Sagnac or the Wang experiment. Okay, they found that the speed of light is c plus v. Okay, the v we interpret as the speed of the ether that's created by the motion of the mass. In the case of Sagnac, it's the rotating disk, so you get a rotating vortex. In the case of Wang, he has a glider that goes back and forth, and it drags the ether along with it at the same speed, and that's what measured. So what that means is that the speed of light c must be measured relative to ether. If the ether is at rest, if you're in the ether frame, then you measure c. And if your ether is moving and you are in the ether frame of reference, you also measure c. But if you're in the earth frame, the laboratory frame, and ether is moving past you at v, and you measure c plus v, which is exactly what they measure in the experiments that I cited.
Right. So that actually fits perfectly within my interpretation of light, which is that it is ether. So like that the light actually is the ether.
It's an excitation or some
Exactly.
way yes, like you excite the levels of the electron in an atom, make it jump from different levels.
Yeah.
In some way that we don't understand, the ether has different levels of energy, and that's apparently what's happening.
Yeah, it makes sense to me, right? Like if I'm going to throw a football 40 yards as hard as I can and we time how long it takes to get there, but then I jump on a motorcycle and then floor it and then throw the football 40 yards, the football is going to get to the 40 yards faster.
Mm-hmm.
Right. It's basically, it's like the motorcycle is in this case connected to me and it is in fact the football as well. So it's kind of falls apart, but like, so I think, so okay, cool. We're in agreement. Then the light actually is just a perturbation or an excitation of the ether itself, and that movement within the ether is going to manifest to us as an increase in the speed of light. So what that would actually mean is, in very technical terms, there is no such thing as the speed of light. As in, there is no such thing as light physically traveling from point to point. It's kind of already there. We're just seeing it faster, right? Like I mean, this goes down a rabbit hole, but
yeah. You don't see light. You only see it when it reflects off something or it interacts with matter in some way, but you don't see a beam of light unless, there's some smoke, which means, again, it has to interact with matter in order to be observed.
Right.
But otherwise, in other words, light, when it travels, is in darkness. It isn't light. That is, it isn't visible.
Yeah, exactly.
That's
this.
now
Does
another
this
thing
fit in?
to
Oh,
consider
go ahead.
is the mainstream argument that that the stars can't be rotating around us, but the Earth must be rotating, is because of the tremendous speeds that would be required. Even if we say the stars are only 100 light years away, not billions, even if we say that, there's still tremendous speeds far beyond E that are required to explain it. And the way we explain it is it's the speed of the ether in which the stars are embedded. And the chart that I gave on the slides for Atsukowski indicated that the second velocity of light is 10 to the 43 or more. Okay, so that's beyond comprehension, a number so big. And that would explain, no matter how far the stars are, how they could be moving at tremendous speeds. No one has measured the speed of the ether itself. We've measured light speed, but we haven't measured the speed of ether.
I mean, would it even
Yeah.
be possible if we're in it? No way, right? We'd have to be outside of it.
Well, you'd have to have something to
Well,
measure in relation to. Yeah.
Right.
Exactly. You need an object that's moving in the ether in order to detect how it's moving. Yeah.
Right.
So yeah, that makes perfect sense, right? I mean, effectively, there would be no conceivable speed limit. So, and yeah, that is the number one thing I always hear, right? But one thing, I mean, I don't really vibe with Newtonian mechanics whatsoever. Like, I think it's like completely wrong and archaic, and like, now I will admit that like some Genesis approach obviously answers one of the major problems, which is that It doesn't account for a time variable, meaning it's instant, right? But you have the ether, it can be instant. And then just like Newton said, you have the medium that's it's in mutual contact. So, it can be instant or whatever. But like there are many reasons why Newtonian mechanics don't work for me. Like the idea that there's some force that's inherent in matter just doesn't, I mean, that's just a ridiculous claim to me. So I'm curious that there's like this major, it's crazy because to try to figure out gravity, it almost appears that you have to figure out cosmology first, which seems backwards, but like, my understanding is going to be distinctly different, right? Like I would say the creator is actually physically present above us and physically loosely used. And we're just kind of within the vortex and he's a central source, causes this motion that is the overall ether drift, which can go as fast as it needs to. In fact, it goes faster and faster the further out it is from this central position, right? And then there's a disturbance. There's like a constant disturbance or vibrations within that ether. And it's like if I put sand on a table and turn on like play music through a speaker, the sand's going to move in relation to the vibrations, right? And so like I think that's really all that gravity is. I don't even think it's point specific or anything like that. I think it's just an effect, and so then you need the cause. And I would actually say the primary mover is the cause. So what do you think about that?
Well, you're saying that in the case of the sand on the speaker, you're saying that the air plays the role of the ether, right?
Yes.
Yeah.
It's a crude analogy. It's just that the sand is displaced relative to the vibration. It's just to convey that simple concept that like if there are vibrations in the ether, anything that is within that is going to move accordingly, right? It's going to be displaced. I think that's all gravity is. And so I think that that vortex itself is created by some central source, right? And I would say that's the creator. And I would say that everything is moving in relation to that. And as it moves through there are vibrations or ripples going through the ether. And so whatever's in its proximity will be affected by the vibrations coming from that quote unquote body. Does that mean like will just be displaced? But it's all going to fit within I don't know. It's hard to even convey it. It's just like it's a standstill here where like there has to be something that we would call a force causing the motion. And Newtonian gravity pretty clearly doesn't work. So I don't know. I feel like we're left with something else. We have to come up with something else.
Is this why there's modalities of ether? I've heard of this. I'm not really too familiar with it, but I've heard someone say that there's modalities of ether.
I think everything is that. Yeah.
Okay.
That's just my opinion.
There's different types. There's a solid ether, which is the one that rotates around the universe centered at the Earth, and it's a rigid rotation because the speed of any object in that ether is proportional to the distance from the center, and that's cited in the Bible as the firmament. All right, what was created between the water above and the water below is what we would probably call the solid ether. Now we talk about ether winds. The ether winds are obviously not solid. So we have a problem. Does ether come in different flavors?
Like water?
Does it have different phases? Yeah, like water. We say water, but is ice water? In some sense, it's water because it contains water molecules, but it isn't water in the liquid state. So we probably have the same situation with ether, especially because ether, if it's the substance from which everything is made, must have all of the properties that the material properties have. In other words, there must be as much potential in the cause as appears in the effect. This is called philosophical realism. or sufficient causality.
See, I
My,
I
the-
relate
my theory.
to
Go ahead.
water. No, yeah, I relate water very much to ether, like water, light, and then you would call like the human spirit, like the three modalities of humans or of God in a sense, where it's just like water has like different modalities. Light has different modalities in a sense, wave and particle form, and it has a
Sound.
function.
I'm sorry I interrupted. I had to throw that in there.
Sound, yeah, like frequency, light, vibration, right? It's always these threes, like these combos. So I'm just kind of trying to wrap my head around ether in general. It's kind of a new subject to me.
To everyone.
Yeah, I think we just nailed the analogy though, right? I mean, so like you have vapor, liquid, and ice,
Right,
and they're all water. They're
right.
just different modalities of what we call water.
I like
Water
that analogy.
stream.
Some people say plasma is a fourth state of matter
I was gonna get
because
that.
it's the electrons stripped off from the atoms. So you have a mixture of ions and electrons, like you have in the sun, for example. And that's considered, in some people consider that a fourth state of matter.
Hmm.
Yeah, that's interesting. Yeah, I can see that. I can see a debate there, but yeah, it's because it seems because then you have to get into what is charge.
Right.
Right. So what is charge? Yeah.
What if
Good question.
plasma or lightning, as we see it, is just the result of the system trying to get back to equilibrium?
I think that's for sure what it is. Yeah.
Well, yeah. Isn't that exactly what it is?
I would
It's
say
like that.
well, yeah, but I would say I would say specifically, lightning is dielectric discharge
Right.
on its way back to counter space. When counter space just being the primary state of the ether, like the non-detectable, non-directly detectable version, which is crazy because now we're getting into dark matter territory, basically, right? Like, oh, non-detectable, but yeah. Anyway, that's my understanding of it.
Well, I always found that interesting, dielectric, right? Positive, negative. And then you see like 0, 1, and then 2. Like you see them trying to equivocate the oscillation between both of them, right? That charge, that stream. And you see it all the time. Like you have on, off, and then the oscillation between on and off, right? This is what they call quantum and stuff like that, superpositions, etc.
Standing waves.
Standing waves. Yeah, like there's always there's like a third aspect that's we're all trying to like kind of like grasp onto, and I don't know. I love these conversations. So
I think static electricity is the ether under stress. I think that magnetism electricity is the ether in motion, and that's not my idea. That's like just Tesla's idea. But I'm curious, kind of like what Robert. People bring up stellar aberration a lot to me. I have my own way that I address it from a stationary Earth position. But if someone were to ask you, like, how do you explain stellar aberration if the Earth is stationary? What would you say?
You gave a great explanation. I think that's how we started. Actually, when I came in, did you guys start with Aries failure? Because that's what I wanted to ask.
Oh, well, then sorry, you don't have to repeat it. Then I was late.
Aries success.
Yeah. So I think so. Aries failure was up when I came in, but I didn't. I assume you guys started with that, and then started with parallax. Maybe.
Yeah.
It's all right.
That's generally how the progression went.
It's okay. It's okay.
I missed the beginning too, so I wouldn't hate a repeat.
No, yeah.
One of the greatest experiments of all time is Aries failure, because it showed that the Earth is at rest and the ether is in motion. And no one has disproven that in the 300 years since he stated it. So I recommend going to Aries. Aries success.
Aries
success. Yeah, I didn't put that.
I made some modifications. Yeah, I made some modifications to that.
He's changing on the fly here.
Dude, it's great rhetoric.
So I would recommend, if you understand the logic of that and such a simple experiment, all you need is a telescope, but it has to be quality so that you can measure the small angle of the aberration. And all you need is water and a telescope. And you can prove logically the two things I just said. Earth is at rest, and the ether is bending the light before it comes into the telescope, which proves that there is a moving ether in space.
Alan, can you go up one
It
slide?
it
Yeah.
destroys
Yeah.
everything,
Yeah.
everything they claim.
So basically, the really quick, concise answer would just be that it's caused by the motion of the ether.
Yeah.
Yeah.
I love it.
Yeah. We're on the same page. Kosho
And then
couldn't get there.
Yeah, it started with Kosho yesterday. The other thing that Kosho was talking about that I would like to ask about to totally change the topic is the ECI frame in terms of GPS.
Yeah.
Just because I think our Globe Lad friend has come up with a completely different understanding for the significance of why they have this ECI frame that runs counter to yours, I's, and Alan's, and which is an interpretation of what the ECI frame was for. Isn't that the one that you said was synchronized with Earth and sidereal time? So it's like the 6-month sun and 6 months dark, but has no bearing in reality. And is the frame they have to create in which to make measurements actually like measurable to heliocentric lore and to negate the C plus V frame?
Yes, you said a mouthful, but that's correct. Yeah.
A long question.
Dude, Shane does that, bro. He hits you with that large summary.
You know, it's funny. I'm trying to look up Aries failure, and I just keep seeing these like flat Earth debunks things. I'm trying to find like actual.
Maybe you should try Aries success. You got to change the terminology up. You got to trick Google.
All right.
Yeah. Yeah, when
Anytime
people
there's a
started
famous-
asking, yeah, go ahead. You're good.
No, you go ahead.
I was gonna say, I forgot what I was gonna say, bro. You're straight.
Oh, I was literally saying something other than, like anytime that there's like a really famous test they say is a failure, it just that's exactly where you need to go look, right? Like they call Michelson-Morley the greatest failed experiment in history.
Right.
That was a great success, though, right? So
Well,
I just
it a
never
null
heard of
result,
Aries.
and it wasn't. It was not a null result.
exactly. And dude, I was talking. This is what's so crazy, man. The stuff we run into trying to break this down to people. They're like, I'm like, you know that Michelson-Gell-Pearson was in 1925, right? So that was, many years later, decades later, and just go read the first page, and they assumed a fixed ether and that the Earth was spinning through it, and they were trying to measure the velocity of light in proportion to those things, like the rotation of the Earth in this fixed ether. And so what they have everyone saying now, and Wikipedia does as well, is that Michelson-Morley debunked the ether. I'm like, that's crazy, man, because I guess they didn't get the memo. 4 decades later, they're still using it as the very foundation for their math to predict the fringe shift. All that to say that, like, really, that's another direct refutation. It's existed for almost a century, which is that assuming the fixed ether and the orbit of the Earth, you do not get the fringe shift that you're supposed to get. But then assuming a fixed ether and a rotational Earth, you do get this ideal rotation fringe shift predicted, which means literally the only viable explanation is that there's a rotation and there's not an orbit, which means the Earth can't be what's moving, right? Like, I mean, am I mistaken, or is it not just like literally over right there? I mean, that's not anything new.
Yeah, the most general way of stating this would be to say, in kinematics, which is measurement, relativity is valid. What does that mean? It means relative motion is valid if you are moving with a speed v in a direction north, then I see from my point of view, I see you moving south at the same velocity, and so on for accelerations and higher derivatives. Relativity only applies in measurement. So things like the Foucault pendulum or the Michelson-Gell-Pearson experiment, which claimed to measure the rotation of the Earth, and they were really happy. They said, yes, we measured 24 hours. No, you measured the rotation of the ether around the Earth 24 hours. And there's no way you can distinguish just by measurements which one is which, because relativity is valid in kinematics. So those arguments that claim that they measured 24 hours for a Earth rotation have to explain how it could be the Earth that's at rest and the universe or the ether that's rotating around it at 24 hours. And they can't explain that because it would violate relativity. So that's a general argument I use for these discussions of, well, this experiment proves it and that experiment proves it. It comes down to they're assuming that there is an absolute frame that they're using, which they can't if they're using measurements.
Yeah, absolutely. Yeah, ironically, they have to make your argument for you, right? Like they have to be able to defend the flip side.
Yeah, the argument about relativity centers basically on a misunderstanding. When does relativity apply? It applies in dynamics when you're trying to predict something, not when you're measuring something, because then relativity always applies. And then you have to distinguish. Some people use special relativity as though it is Galilean relativity, and you can't mix those two, because the two postulates of special relativity are obviously incorrect. Light has different speed than c in the Sagnac and the Wang experiment, and the first postulate is wrong because the only inertial frame is the Earth, the laboratory frame. It's the only frame in which you can make predictions, and Newton's bucket proves that. So that's a summary.
I forgot about the good old Newton's
Summary of
bucket. That was a great
what
one.
I believe.
I love
Well,
it.
I mean, I feel like it's a fact, right? Like I can't. I've tried to stillman the other side, and there actually isn't an actual rebuttal to what you just said. I can't think of one. You know, specifically that you're able to detect the like the sidereal rotation of Michelson-Gale-Pearson combined with the inability to detect the orbital velocity. It's the same exact technology, right? So, I mean, yeah, sure, they will try to say that, like, obviously their get out of jail card was like, oh, you just can't detect linear motion, right? I mean, I guess that's their get, but that's been disproven. So, and I don't even think that works.
I mean, like, what do the Globers say when we bring up Wang as the linearized the Sagnac effect in 2004? Don't they just like blank stare or say "nuh-uh" or?
Pretty much.
Yeah.
Yeah.
There's no refutation to that.
Yeah. So what I noticed is like they split, interferometry up into two categories: circular and linear. So they got your orthogonal apparatuses for the linear, and then they got the closed circuits for what they say is detecting, angular rotation. So that's kind of how they've divided it up for everyone. So like the orthogonal devices link, contract, and time dilate, but the circular closed loop ones experience little pockets of link contraction and time dilation due to angular rotation. So it's like slightly different mechanism or whatever, but like they divide it into two separate things. And then like you said, they said that the linear can't be detected, therefore it's only the rotational. But as Wang showed, like not only is the mathematical derivation for both predictions the same, the linear motion is fully detectable. So, GG.
Let's see. I can't believe you say little pockets of space time and time dilation and complete seriousness every time.
Little temporal pockets, bro. They don't really talk about Michelson-Gale-Pearson, bro.
I know, that's what I'm saying. I'm like it's wild, and they're like they didn't assume the Æther. I'm like, buddy, just go read the literal first sentence of the paper.
Yeah.
Like,
And then down here at the math section part, they say they calculated the displacement on the assumption of a stationary Æther as well as the accordance with relativity. So there, when you get into your Paul Lavoux metric tensor of angular rotation conservation and all that. But yeah, the basic derivation that they didn't, doesn't need any of that. So, but they just throw this in there like, oh, it's also in accordance with relativity. Cool. Which one? The one that says that the speed of light changes or doesn't change? It's like, yeah. So you're saying like, yeah. So you're saying like at altitude, you wouldn't get 15 degrees per hour at the same latitude. You would get more because it's spinning faster, right? Because you're closer to. Gotcha. Yeah, that's what you would think, right? Like that makes sense to me.
Yeah. I don't get how it's 15 degrees everywhere on Earth.
Mm, all that they
Yeah.
can say is that you can't detect linear motion.
Yep.
So they have to say that Michelson-Morley was instrumental error. You can't detect linear motion because even though we're on a geodesic path that's free falling, and so that you can't detect it due to like constancy, basically. That there's no changes, just linear motion. And then with the Sagnac you can because it's rotational. So as soon as you show that you can detect linear velocity with interferometry, they literally cannot say anything. I mean, as it pertains to the altitude, there is no answer, right? Like because it has to be C, and the drift has to be relative to latitude, right? I mean, I've never even heard anyone pretend to have an answer for that. They just say, nah.
No.
Oh, there it
Bro.
is. My favorite slide.
Yeah, the what was it? I asked, I can science that about it, and he basically wrote off the Wang thing and said that it was just a mathematical prank and Wang was just joking or whatever. So I was like,
What?
I was like, yeah, that dude, that was a legit response to like the Wang thing because I showed him the Wang paper and was like, what's up with this linear motion? And yeah, he got back to me like a couple days later and was like, yeah, he was like, I was thinking about it, and I think that Wang was just showing that it was a cool mathematical trick and that there's no like significance that it disproves special relativity. And I was like, okay. And then I just like looked into it on my own and was like, well, that's not it's not good for you guys. But yeah, there's no answer for it, bro. That's just complete check out, shut it down, and it's a prank. It's a prank, bro.
Mathematical joke. Wow.
Math prank.
So I mean, I wonder.
That's
Yeah.
one of their strategies: derision, ridicule.
Yep. Get
One
the
of
dissonance.
one of the elements of their toolbox.
Yeah. Oh yeah. We know all too
Yeah,
well.
we're very familiar with those tools
Just
that are used
Google my
on us all the
name.
time.
Just Google my name. Well, I don't think there is an answer. I guess now now the step is to just try to figure out. I don't know. We're kind of limited to speculation though regarding this. I mean, so I don't know if you guys know, but we are going to put together like an actual pendulum test. I'm curious, Robert. So I know that the glob is on the table, right, for you and Robert, but like, so then you'd be application of the Machian principle for like the drift of a pendulum, similar to Luka Popov, his analysis, or more so like I'm sure you're familiar with I don't know how to say his name, Andre Assis or whatever, a relational mechanics where he breaks down the dynamic equivalent.
Oh yeah.
Alan
Robert,
and I were just
tell him about your
discussing
boy Zeus. Yep.
just before we started this session. I got a feedback from Andre Assis. I had seen his video, Austin, on Mach's principle, and I wrote some comments inserted at different timelines, time marks in the video. And I sent it to him, and I sent the copy to Alan. And I sent it also to Alexander Unziger, who you may also have heard of, because he hosted the show. And I just got an answer back. It said, "Thank you for your response. All the best, Andre." I had asked him about 5 questions related to why did some of the things that you say contradict experimental evidence, and of course that was the answer I got, and that's typical, either ignore or ridicule. So
Yeah, that's basically
that's
like
where we
tapping
are.
out. Yeah, I agree. That's where we are for sure. That's crazy. That sucks because I had high hopes for that guy. See, he makes some interesting
Yeah,
points in his book.
he's a dissident, but he is basically mostly mainline. But electromagnetism and the relationship to mechanics, since he wrote a book on relational mechanics, he has some issues with that. But he is basically mainstream. I'm hoping for a response from Alexander Unziger because he seems to be more of a rebel. His videos speak out clearly when he sees that they're abusing logic or experimental evidence. Interesting that you mentioned Assis, though.
Yeah, it is funny. Yeah, so yeah, because the pendulum is an interesting thing. I mean, I started really deep diving in this, and there's like no legitimate verifiable evidence that the pendulum actually drifts as predicted based on the globe. That's actually not a real thing. So there is actually no consistency of that effect. I don't dispute the effect in entirety, but I certainly challenge the claimed deviation. And I was trying to look into it last night. I'm actually creating a group, but it doesn't exist. It's almost impossible to not impose lateral bias onto the pendulum. And it's not consistent at all. And there's basically no experimental evidence past from the equator down. It's never been documented in the history of mankind, as far as I can tell, that the pendulum doesn't precess at all at the equator. And there's like basically nothing south of that. So all that just to say, I mean, who's to know if it's even a legitimate effect to be explained? But I'm just saying, I guess you could, of course, the translation of motion from the sky down could cause that drift. I guess is kind of that's where I would land if you had to explain it. Have you heard of the? I'm sure you've heard of the Elias effect.
I mean, during the eclipses?
Yeah.
Yeah, I have heard of it. I didn't research it in detail. I think it's been documented by Hector. Oh, I don't know. His first name is Hector, and his last name is Spanish. But yes, that's an interesting effect. It seems like the gravitational effects occur before the optical effects begin. That is, before the eclipse starts, you start getting you get the pendulums that they're using to measure gravity. They start to oscillate strangely before the light reaches. So if you're saying that the moon is blocking off ether coming from the sun, either it's diffracting around the edge of the moon, and that explains why it can appear before the edge of the darkness starts, or there's some other reason. And I haven't researched it too much, but I think it's something good to look into.
Yeah, it's very interesting, right? I mean, that would be like an absolute problem for the mainstream model as well. I did read a paper, and I'm not brushed up on it, but basically it depends on which type of pendulum that you use, and I think the more advanced instruments are unsuccessful in detecting the effects. But that would obviously show that the effect itself, right, like is coming from the sky, to put it simply, right?
Well, yeah.
Yeah,
And
exactly.
it has something to do with the eclipse because it happens just before the eclipse. And I think it also occurs just before the eclipse ends. Instead of at the end, it begins before the end. So that has to be explained. If it's strictly a gravitational effect or an optical effect, then why does it have this deviation from where it occurs? It doesn't correspond. The light and the gravity effects they're not synchronized, and I don't have an answer for that, but I haven't looked into it in any deep sense.
Yeah, same. I'll have to try to figure it out. I want us to replicate it if possible, but
Yeah, I would like to have an explanation for why eclipses would affect things like that. That would be neat in any model.
I think Allais is spelled Allais, if you want to look it up.
yep. And I do have this paper right here. This is a guy, I don't know exactly what his explanation is, but he claims to have one. And I'm sure he's coming from the mainstream perspective as he actually popped up on Google. So, whatever that's worth, but it may help aid that. And I'm currently trying to get my hands on Dayton Miller's raw data. I have not got a response yet, though.
So you sent it?
What?
Yeah.
No more today, huh?
Okay, but let me tell you guys this, okay? So I have a sit down meeting Friday with a friend and a couple of like pretty big producers, like Hollywood producers, and they want us to basically co-host a video. I mean, like a documentary style, whatever. Right? And obviously, you guys probably know that the history is that they create hit pieces.
I was thinking Jaren right off the bat.
Wow.
Yeah. So you have to have final editing rights. But what they've suggested is that they will provide funding. And so while we're discussing this, like for tests, so while we're discussing this thing of like, well, you get no response, you get ridiculed, right? They've evolved to these tactics. I'm saying if we create a list of certain tests, if we're able to get it into something like that, I think we can all kind of agree that the evidence is already there, right? Like Robert just laid it all out in those presentations. There's an abundance of evidence that's, specifically refutes the claim that the Earth is moving. So don't you think that a modern replication documented in like 4K in one of these bigger videos would be beneficial? I don't know what your guys' take is before I go, though, because you could also argue, well, okay, these are somewhat nuanced and complex tests. And if you don't accomplish it, you know how they go. They'll chop it up, run with it, and be like, oh, look, the stupid flat earthers disproved themselves again.
Have someone help you underwrite. Seriously.
Oh, like the contract?
Yeah.
Yeah.
But like really though. And
yeah,
have
I have
that
I have an attorney, bro.
No, I know, but what I'm saying is have them incorporate that into the underwriting part.
Well, final edit rights is like the safest bet, right? Which means that I have to stamp on the final version. I'm not really trying to change the conversation. That I was just asking if you, off the top of your head, like, do you guys Can you guys think of any specific tests that, yeah, you would think would be valuable? I mean, obviously, I can't just walk up and be like, "Hey, look, here's a paper from Wang," right? Like,
Yeah, try to land land an airplane on a spinning ball.
Okay.
Yeah, I'll hit you with a couple suggestions in a bit.
Yeah,
I
give
got a
me some
couple
time
things
on
here.
it. I'll help you out. But like, what do you like? What experiments did you have in mind?
Oh, I don't know. I mean, it depends on which conversation you're talking about, right? So, like, when it comes to the planar nature of the Earth, like the horizontal line of sight microwave and radio transmissions right through the skip zones.
That'll be interesting.
Well, that's
That'll
just
be
that's
Yeah.
direct physical refutation of the globe. There's no way around it. Like as it pertains to
That'd probably be the
motion,
cheapest one too, right?
yeah, it's definitely pretty attainable. Yeah. As it
Yeah.
pertains to like motion, now I mean that's like a whole can of worms, right? I mean, you would like to two birds with one stone show like, okay, it can't, not only can it not be the Earth moving, but the ether is, and maybe a modern airy success. Yeah.
I was just gonna say it.
Yeah. You guys just let me know. I'm just throwing that out there because I have the meeting Friday. Well, that's why you need like a Netflix. That's what I'm saying. Like, it's not even about the information anymore, right? It's about the. Yeah, yeah. I mean, yeah, it's a bit. These are a bit nuanced subjects. It's kind of difficult. Robert, real quick, what do you think about? So, I'm sure you know some about how like quasars are like a big problem for modern cosmology because of their redshift, and I was kind of thinking like from where would quasars, and it's obviously okay if you don't know an answer, but like where would quasars kind of fit in your idea of these kind of background stars guiding the internal motions? If meaning if that's the causal agent of the redshift, and you know we have these quasars out there. What people call quasars a quasi. I mean, they don't know what it is, right?
Mm-hmm.
Yeah, like what's your kind of take on quasars and like their immense amount of redshift?
Yeah, quasar is a quasi-stellar object, and they were discovered by, among others, Holton Arp, for which he lost his job because he showed that it was some of them were connected physically to stars that had quite different redshifts, so they couldn't be at quite different distances and be physically connected with a jet of matter. So the quasars could be just like we have different personalities as human beings. If stars are in fact representations of angels, then they could also have their own personalities. That personality could include the amount of redshift, or in my interpretation, the amount of ether that they use to descend with the light that comes from them. And that would be a combination of a physical and a spiritual or an immaterial interpretation.
Okay, yeah, that's not too far off what I think. I think that's pretty interesting. It makes you think like, man, quasars may be something pretty crazy, huh? They may be like pretty epic angels or something.
But imagine losing your job because of pointing out that quasars are linked to stars that are supposedly much closer. And he can only use European observatories because he's been blacklisted at all the American universities, observatories.
Yeah, that's crazy, man. You got pissed too, man. Dropped seeing red. It's crazy because he was like revered before that.
Good astronomer.
Yeah, man, he made like an epic catalog of galaxies. That was like, revolutionary at the time.
Alan just going through his library, showing off relevant
Dude,
PDF as the books are being
Dude's-
discussed as a passive background entertainment. It's cool.
Dude's got quite a collection.
Is he? Are you changing the title of my slides?
Only if it's
Yeah.
relevant.
A little bit.
He's gonna make it a flat Earth presentation before it's over with.
Yeah, before you even
Yeah.
know it, you'll be with us.
Yeah.
The only thing I
And
have
it
to add in
promotes
is
flat
this-
Earth. Yeah.
curved visual
Well, we
space,
we
and
agree on
go.
lots of things. We don't have to focus on the one little tiny thing we disagree on.
Yeah,
One
we're gonna
little
throw a
cord
party
just-
for you in person when we get you over here.
Well, they say there's 3 things that cause enemies to become become. Let me say this right. Cause friends to become enemies, and that's talking about religion, talking about politics, and talking about flat Earth.
I saw that one.
That's so true.
Yeah, it is funny though because a lot of flat earthers are a bit over the top. Like when I was talking to Robert, bro, the conversation was amazing, and you got people like triggered, like talk about what you disagree on. I'm like, bro,
Yeah,
what's wrong with
I
you
saw,
people?
I saw
They
the
just want
comment.
conflict.
Yeah, that's
Like,
Yeah, man.
I
doesn't
don't
get
know.
anywhere.
We're
Well,
just
they're like,
sitting there
hey.
unloading magazines on the heliocentric model, and they're like, that's not enough.
Yeah, it's like I agree with 99% of the things you said, but that one thing, can we focus on that perpetually?
Yeah.
Like, what?
Perpetually, dude. Can we just hammer it into the ground until there's nothing left except for mutual hatred for it?
It's like, yeah, we could do that, or we could do
It's
the
not a-
opposite of that.
It's not a permanent Hegelian dialectic or anything,
Yeah.
No.
You guys heard they just came out and said that Mind has been falsified with Sigma 16 confidence.
Ooh, that's a high sigma.
I don't even know what the fuck you just said, to be honest.
Modified Newtonian dynamics.
It's okay. Your
As
brain
an
isn't much.
explanation for dark matter.
Yeah, or as an explanation without dark matter. Yeah, they when modified Newtonian dynamics was applied to certain clusters,
Oh, man.
they still needed dark matter. The math still needs dark matter, and so they're saying that it's been falsified with Sigma 16 confidence. This is, of course, on the heels of a few weeks ago that astrophysics professor from Australia coming out and saying dark matter's been falsified with Sigma 5 confidence. Right, like they're one-upping each other or something. Because he's a
They
Mon
really are.
proponent. Yeah.
So they're just
So-
in a mathematical Hegelian dialectic?
Well, we're just sitting over here, like never having to change anything.
That's a great point.
Just watching
Yeah,
them
that's-
struggle
I
to mathematically
know,
figure it out while we're just
That's a
like, yeah.
Pretty base
so-
point. Yeah.
The spider must weave its web.
Mhm.
Dude, that's trippy. It's trippy to think about.
Would you want to discuss the dark matter theory?
We's
Yeah,
itching.
absolutely.
Yep.
Do it.
Absolutely.
Okay. The way it started was that Fred Sawicki and Vera Rubin, 2 astronomers, noticed that if they look carefully at the rotation of stars and galaxies, that they weren't obeying Newton's law. Newton's law says that the speed of something going around the sun is what 1 over the square root of the radius. But what they were seeing is rigid body rotation. They were seeing that the stars rotate at the same angular speed as the stars inside. So in other words, the galaxy keeps its shape. If it's a spiral galaxy, it remains a spiral galaxy because all the stars move with the same angular velocity, which is called rigid body motion. This was a surprise to them because they thought, well, Newton's theory is obeyed in the solar system, and it should also apply to the stars, but it doesn't, and not according to observations. Now, the Æther theory says that the universe rotates because the stars are embedded in a solid ether, so that the rotation of parts within the universe should also rotate with with a speed that's proportional to the radius. In other words, rigid body rotation. So the whole universe rotates as a rigid body, and so also should all of the pieces, which are the galaxies, they should also rotate. And so the ether theory at least suggests that the rotation of galaxies should be the same as the universe itself, and that's what is observed. Now, how do we explain the Newtonian deviation from that? I already explained it with the ether winds that slow down motion in the solar system so that it agrees with Newton's law. So Newton's law is created, in effect, by these ether winds that blow from outer space, from the stars, and slow down the planets and the sun and the moon and cause them to obey Newton's laws. So that's the explanation for dark matter. It isn't because of invisible particles that they haven't discovered yet. It isn't due to anything else except extending the concept of rigid body motion for the universe to the galaxies themselves, and then explaining why it isn't obeyed in the solar system by the ether winds of Hildegard. That's it, guys.
Robert, I got a question real
Damn.
quick before I lose it. Is this why Newton basically said he thought that gravity was like bleeding in, like bleeding into to our universe, basically, in a
Did he,
sense?
did he say that in the Principia?
No, I seen it in a documentary about it's like called The Dark Heretic. You know, the mysterious manuscripts of Isaac Newton and his like personal writings that James Maynard Keynes found. And like he had this unpublished paper called The Vegetation of Metals, and where he stated he thought that gravity was something that was more like bleeding into our universe, almost like Max Planck kind of thing. But no, yeah, I don't know. I don't know if you ever heard of that or heard that from Isaac Newton. It
No,
just
I never
reminded
heard
me
of
of
it,
it.
and I'm not sure what he meant by it. I do know that because of his optics experiment, Newton believed in an ether, but then he said, if there's an ether, then the planets would have to go through, uh, orbit through this ether, and that would slow them down, and the planets would spiral into the sun. This was also the belief of Feynman. Feynman said that he didn't believe in an ether because of the same reason, that if there were an ether, it would retard the motion of the planets. And of course, they're using a model of a stationary ether, an inflexible ether, and something that causes resistance to motion. Actually, as we know, ether is dragged along by the motion of matter, and that's what causes all of the effects that we measure with Sagnac and with Dufour-Prunier and with Wang.
Yeah,
So
you did it. That's I mean, Newton did end up saying, right? He has this quote right here. It says, "May not planets and comets and all gross bodies perform their motions more freely and with less resistance in this ethereal medium than in any fluid, which fills all space adequately without leaving any pores, and by consequence is much denser than quicksilver and gold. And may not its resistance be so small as to be inconsiderable? For instance, if this ether, for so I will call it, should be supposed 700,000 times more elastic than our air and above 700,000 times more rare, its resistance would be above 600 million times less than that of water. And so small resistance would scarce make any sensible alteration in the motions of the planets in 10,000 years." And that's Isaac Newton in Optics, question 22.
yeah, I'm glad you mentioned that it's optics, because it's optics that led him to believe that ether was possible. It was in mechanics, in the Principia, I believe, that he thought ether was not possible because of the reason I gave. So it was optics that gave him the idea of ether, but because of his idea that friction between ether and the planets would cause them to spiral into the sun, that he rejected that idea.
Right, and then he ends up kind of migrating to this idea of something akin to a superfluid, basically. So, that what do you think about that? I'm sure you've heard that they're kind of coming out because you broke down dark matter like incredibly elegantly. Like that was double adverb, but so like they're now saying they're proposing the idea of one SVT, superfluid vacuum theory, and they're also proposing dark matter superfluidity, right? Being as they're like, oh well, the prerequisites for dark are for superfluid are that it's really dense, like tightly compacted, and super cold. And so well, they got the cold dark matter model. They're like, okay, well both both requirements are satisfied, and they're trying to explain this or use this to explain the lack of resistance that we see where they claim dark matter is blah blah blah. But all that to say, like, do you think that ether may behave similar to superfluid? What is your take on a moving ether or movement within the ether, and it's like any resistance? Like, do you think that it creates resistance or has viscosity or behaves akin to a superfluid? Like, do you have any take on that?
Yes, I do. It's based on philosophical principles, which go back to Aristotle, and it's called scholastic realism. There are two principles of change. In order to have change, you must have matter and form. Matter is something that is capable of changing and can receive instructions from form, which is a list basically of all the potentials or possibilities that matter can have. So if we think of ether as being a physical representation of matter, and prime matter is considered to be something which has completely no previously defined form, then we can say that change occurs. And by change, I mean everything that happens in the physical world, everything that changes state is a change from matter to form. If we consider that's the case, then possibly ether is the Aristotelian concept of matter, and the form is the set of potentials which exist for changing that form, for changing the matter. I'm sorry, changing the matter. Now, you know that quantum mechanics has this theory, well-formed theory. Changes occur because of a change in the Schrödinger equation, which imposes changes on a wave function. Now, what is a wave function? It's a set of mathematical probabilities. Well, bingo. I've used the word probabilities in quantum mechanics, and I use the same word in philosophy for Aristotle's theory of change, hylomorphism. In other words, what I'm saying is that the ether may be what we consider philosophically to be the blank material, unformed, undifferentiated, as they say. And it is what form imposes on that, the set of possibilities. So when a sculptor starts sculpting a statue, he starts with a chunk of marble. The idea that he has in his mind of what is going to be the final form of the statue is in his mind. It's not in the statue, but it's potentially in the statue. Otherwise, it couldn't possibly occur. If it wasn't possibly able to be formed in the way the sculpture wants, then it wouldn't exist. So Aristotle had this idea that what you have in your mind to do is an example of potentials, what is possible for you to do. That's basically what I think ether is. It's the basic substrate from which everything can be changed into something else.
Did you say pleomorphic?
Excuse me? Hylomorphic.
Did you use the word I'm sorry, say it again.
Hylomorphic. H-Y-L-O.
Pylomorphic. Okay, because I've heard of pleomorphic, but not pylo. Okay.
Let's see. Morphous means shape, and hylo means form. Or matter. Hylo means matter. So, it's a nebulous definition. Yes, it's philosophic. But if ether is to be responsible for not only the properties that we see in space, but also explaining how atoms can be formed, and from those atoms, molecules, and from those molecules, all of the different varieties of substances, the 92 elements that are natural. In order to have all that variety, ether must have the potential to create everything that is possible. And that's my definition of ether.
Okay, nice. Yeah, so that like obviously in specific scenarios it could have superfluid like characteristics because it could have effectively any range of observable characteristics that we could really put our finger on.
Anything that matter has, ether must have, because a principle of realism is there is nothing in the effect that isn't already in the cause. Okay? Can you get blood from a stone? No, because a stone does not have the potential to create blood. Okay,
Yeah, makes
it's not
perfect
part
sense.
of its nature. It's not part of its nature. It's not a part of its being. So we're all limited in what we can do. That is what our potentials are. That means what our form is. As humans, we have certain potentials. And that's the philosophical view of what ether is.
Well, we align there for sure. I would, yeah, because I would say it's like the primary substrate or substance, right? Everything that we observe is a modality of that. So yeah, I would agree. I like it's just I guess what I'm saying is like if you think about it in its initial state, I guess it's kind of hard to say that or define that, right? But like its inertial state, it's like, well, I guess it's not really. I don't think inertial is the word, right? Well, okay. Let me ask you this. So, like, do you conceive of it as the ether effectively being a canvas, and that canvas is moving in totality, or do you view it compartmentalized, meaning that there's like motion within the canvas? So if I do understand you correctly, it's effectively the whole thing is moving, or both, or
Yeah, well, the analogy again with water, you could have solid forms of water, ice, right? And that's still ether. It's in the bound state. In the water state, it's free to move, and in the gas state, steam, it's even freer to move. So you have different states of
right,
ether.
basically overlapping or like overlaid in a way. So
I think a better example would be ether is like a blackboard with nothing on it, right? So until you write something on it, it can't do anything. As soon as it has a form, that is a trigger to take one of those potentials that it has and make it actual. So that's how something becomes real. It's how something changes. It goes from the state that it's in to a new state. That's what happens when you write on a blackboard, right? You put chalk, and that, interpreted by a human, can have symbolic meaning. It can represent text, it can represent a diagram, and represent something new. If you make that more general, suppose ether were a blank slate, and if the potential is triggered that corresponds to the ether in that state, it will create something new. It will create change.
right, okay, so we're in complete agreement with that, and like a very crude analogy would be like a whirlpool. So then, and I guess the part of it that is appealing is there being no viscosity to the movement in space, right? Like quote unquote space. So like the stars, for example, seemingly they move with no resistance to flow. So like no viscosity in the medium that they're in. And then the idea, of course, being that the movement within that medium or the ether is what's going to allow those stars to go way faster than we can even really conceive of. Right. And so then you would agree that the ether itself is moving faster. Basically, the speed is increasing proportionate to the distance away from the center.
Yes. In the rigid body motion, the rigid motion of the model of the universe. Yeah, that's correct. But you said no viscosity. Remember, Atsukatsky shows that there are kinematic viscosities that were measured. Of course, I have yet to look at the documentation, the hundreds of pages that Alan gave me. But
Okay.
assume that it's true. Okay, but that viscosity can change. If we're talking about an ether in a particular phase, it may have viscosity, and in other cases, it doesn't. And that's the reason it can change, and it can represent all of the things that we see in the material world.
Right. I'm not
Yeah, like
familiar with that
superfluid.
test, to be honest. Like, I don't know I don't even, I'm not familiar with that because I guess I'm thinking if there's something, if it's a terrestrial experiment, obviously, then, maybe there's some interaction with, material. I don't know. I don't know what that test is because, like, to me, obviously, just like on a very fundamental level, the stars seemingly have nothing resisting them, meaning like the consistency and seemingly perpetual nature of their movement, kind of speaks to the idea that what they're moving within is not holding them back, if you will. Right? Unless it is slowing down over time to such an extent that we can't see it, and is it being deflected inward? If there was a vortex, if there was resistance, seemingly they would be deflected inward over time. But that's not really what we see, right? We just see them just going forever. So I guess I'm not familiar with that test. Yeah, so I don't know. What did he do?
If the ether is rotating, it should be subjected to a centrifugal force, a centrifugal acceleration.
Right, but what do you think about the net centripetal? Like as St. Genis would talk about, like the Coriolis being basically twice the magnitude, so giving you like a net centripetal force. Do you adhere to that?
Yes, Bob and I disagree on the description of what that represents, the Coriolis force and the centripetal force and the acceleration of rotation. All three of those things cause changes in applying Newton's laws. And you apply them when you're in a non-inertial frame. So what is in a non-inertial frame? It's one in which the laws of physics are not obeyed. What we've looked at is the bucket. The bucket didn't obey Newton's laws because when the water was stationary to the guy on the bucket, it still had a vortex shape, which indicates that it is subject to a force even though it isn't moving, even though there's no visible centripetal force. And
That's interesting.
The explanation to that, remember, was it was the earth frame that's important because Newton was in the lab or earth frame when he was observing the bucket. But if you're in a rotating system and fixed in the rotating system, and you apply the law of centrifugal force, you find out that it's not obeyed. In fact, you find out all of the laws of physics are not obeyed if you're not in the laboratory reference frame. Now, the way mainstream gets around that is to say there's fictitious forces and fictitious acceleration. Okay? Yes. And that's what Austin is talking about, the centripetal, the Coriolis, and the other accelerating force. Those are present in, they say, if you're in the bucket, how do you explain the motion of the water? Okay, it's forming a vortex, but the water is still. Well, you have to employ the Coriolis force and so on. When I first heard of this in graduate school, I said, the term the teacher used was, these are fictitious forces. So I knew from the dictionary that that meant fake or fraudulent. So I said, I'm paying good tuition. I'm paying good tuition in order to be taught fake physics, right? That's what they're saying. Newton's law is not obeyed, but they didn't tell you why, because you're not in the lab frame. What did they say? Well, Mach said it's due to the influence of the distant stars, right? And Newton said it's absolute space, but he didn't say what it was. Where is absolute space? Where do I put the observer in order to measure absolute space? He didn't say, because he didn't know. But the experiment, I think, pretty clearly shows that you have to be in the laboratory frame. And this is quite general, because suppose the bucket were a bigger size or a bigger shape. Would you still see the same effect? Would you still see the contradiction in the bucket frame? The answer is yes. Suppose the bucket is not 5 feet off the ground, but 500 feet off the ground, and you spin it. Will you still have the same lack of violation of the laws of physics if you put the bucket at a different distance from the Earth? The answer is no, you still have the same violation. And you can test this, whatever, I'm saying. If you put the bucket at different heights, it won't make any difference. You'll still see the same thing. In fact, you can put it in space. You can put it on the space station. You can put it on the moon. Put it anywhere. And somehow the bucket water will still know that it only can form a vortex if it is spinning with respect to the Earth. And so this is violently objected to by scientists because, as you can obviously see, this makes the Earth very special in the universe. It makes Carl Sagan's statement that we're just a tiny speck in the universe a joke. And so mainstream will always fight anything that even taints of a theistic interpretation, of an indication that we are special in the universe and that we have been put here for a specific purpose.
Yeah, they
And
really don't like that, do they?
No, one of the great experiments is Newton's bucket, because it's that no matter where you put the bucket in the universe, somehow it will sense that it only will cause a vortex if it's rotating with respect to the Earth. How's that for an insight?
That's great.
Yeah, very thorough and profound, my brother.
Well, I've wondered about the centrifugal force being called a fictitious force, and how in a geocentric model you get away with, or that there would still be orbits with calling centrifugal force a fictitious force, because it seems like that. I mean, if you're denying that centrifugal force is a force, then you can get away with orbits. But if you're realizing that centrifugal force is actually physics, and you can't just like cancel it out with the centripetal and act like gravity's this tether, how does geocentrism get away with everything orbiting the Earth and still use that same principle of centrifugal force being canceled out?
Well, the answer is you must use the Earth frame, the lab frame, in order to apply the laws of rotation, which includes centrifugal force. The fictitious forces only hold when you're in a frame of reference which is moving with respect to the Earth, the lab frame. So if you're in the if you're in the moving frame, what are your options? Well, you can ask an observer on Earth what motion they observe, apply Newton's laws because we know they work for an observer on Earth, and then transform coordinates into that moving frame. Okay? That's one option. The other is to simply say, ask an observer on Earth what he sees for the motion, and that's what the actual motion is. But in order to create a mathematical solution, you have to add these 3 extra forces. And what is their purpose? To get you back into the lab frame.
Okay. Are there elliptical orbits in geocentrism? Are they elliptical at all?
Sure. Sure.
Okay.
The only thing is,
uneven distribution of mass that way, though.
Yeah. We haven't mentioned Earth satellites. I mean, man-made satellites, right? Not put up by men.
You mean supposed satellites?
Yeah. Okay. Okay. Yeah. I forgot. All right. Suppose the Earth were a globe.
Crazy.
The satellite orbits could be elliptical because they're not bound by the Æther patterns, right, that were established at creation. So it is the orbits of the planets that Hildegard says are circles, but they're boosted at certain points by the Æther winds. But of course, the man-made satellites didn't exist at the time at 1200s. So yes, there can be elliptical orbits, but not for the planets.
Everyone's hesitation is like, how are we going to go into this? How are we going to go into this?
Yeah, I've already decided. I was like, nope.
It's been such a great conversation for sure.
Yeah, no, it's all good.
What do you want to get into satellites about, Robert?
Oh, I think that there is stuff in the sky. What are you guys talking about?
Yeah, no, I do. Like, dude, we got electrostatic tethering. You got things like the ISS. If you look up like the actual test for the proportion of electrostatic tethering, all in the early '90s, they launched all the things that went all those crazy speeds before they did all the testing, and then all of a sudden it was up there and it was already there, and then all the testing stopped.
Yeah, there's many things, bro. There's a drift. I mean, if you look at the math, they basically account for, like with geostationary satellites, they account for basically going into a spinning universe in their math. The inertial forces, they treat them as real in the math. And I mean, you know, obviously the problem, the disagreement here is that they're metal boxes free falling around a ball, perpetually changing direction while simultaneously free falling.
Right. Well, what brings to mind is that one dude you debated who was all about cube satellites. I think that was the one that Toby and I went backstage afterwards and talked to the guy about it, but that was his claim to fame. He was all like, no, but they're cube satellites, and I put them up there, and they go this fast, and I know it.
Interesting.
There's stuff in the sky, bro. I hate to break to you guys.
Yeah. Well, yeah. Circling above us.
I'm not arguing that.
Yeah. Circling above us is different than orbiting around a planet.
Yeah, but I mean, I don't think the most effective approach is to be like allegedly satellites. Hey, I mean.
Yeah, assuming they're in the vacuum of space going around the planet is what I meant. Yeah.
Well, I like the more relevant, connection point of the relevance or non-relevance of the ECI frame when talking about coordinates and how actually they had to invent a lab frame that negated the super necessary effect of C plus V to pretend that it didn't exist.
So I got a question. How are they in the sky if it's not orbiting around a ball in a vacuum of space? What were you guys talking about? Kind of.
Well, that's a good question. It's a good question. I mean, we know there's an ether drift. We know that you have things like quantum locking and magnetic levitation. I mean, like I said, there's actual like inertial
You're on
forces.
that okay.
I don't even think that they have. I don't even think they have to really understand it either. I think that you could just utilize the fact that there's an ether drift and.
Yeah, like holy crap, that worked. Let's do another one. You know.
Well, I mean, if you just go look at what the government's been doing since the 1920s, then I mean, it's not that. You know, they pulled the Nazis over here. They went out south, then they went to the north. They said, okay, let's shut both these places down with the International Geophysical Year in 1957. After they went out there and said 40 countries all agree to monitor the north and the south, then they came super obsessed with the sky. And then they used the Russian scientists' approximation method to determine the brightness of the firmament with different zenith measurements. And then they started shooting high altitude explosions. Right? So, I mean, yeah, they mapped out the sky and they put stuff in the sky for sure.
Nice list, Dave. I gotta add that to my repertoire. That's cool.
The explosions ones, I just got a qualm about. Like,
well, the electrostatic tethering ones are cool.
What do you mean? What's your qualm?
Well, the ones like Operation Dominic and you know Starfish Prime, Bluegill. I'm going by the validity of the footage of these things. Now, the footage could be completely fake, and what you're talking about is actually did happen, where they shot high altitude, you know, bombs as high as they could. But the problem is when you see that footage, it looks so crafted. Like it literally just looks like someone looking at a sun with a solar filter with like really bad CGI graphics. If you look at like the
I mean, dude, they claim to put a camera by a nuclear bomb and film it, bro. Like when we like
right.
They give
That's
us
what I'm
mixed
saying.
films.
Like, what did they like? How do we know what they actually did if they did it at all?
I don't know, but have you seen the document that was declassified in 2000 about the firmament?
No.
Yeah, so the military, the CIA, declassified a document in 2000 because of the Freedom of Information Act, and it's from a Russian scientist, and it says he developed an approximation method to determine the brightness of the firmament, and that it was proven accurate, and it utilizes things like sun halos and various zenith measurements that have different altitudes. So they're saying that they're making measurements of what they refer to as the firmament, and that it has different zenith measurements. The zenith is, of course, the position directly over top of you, right? So that seems to denote some type of physicality, or they would just all be the same.
No, I agree with the physicality of it. The thing that's for me, I'm trying to wrap my head around is these high altitude devices per se that are quote unquote circling around us.
Yeah, I don't know. I think there's plasma in the sky. I think that there's a drift, and I think there's real inertial forces. And I think you can just throw stuff in there. You know what I'm saying? I think that you can kind of catch the drift.
You can ether surf.
So
insane speeds. Yeah.
One thing I always question, like I just wanted to. You've seen the Go Fast rocket before, right?
Yeah. There's a decent rebuttal to that, though.
What my question is, how did it fall back down? If it's just chilling up, like, you know what I mean? If it catches whatever it's catching to make it look like it hit water, how does it just...
There's a mechanism in the rocket that shuts it off, like shuts off the spin of the rocket.
Okay. And then it just falls out of it, I guess.
They do that tactically at a certain place to try to control its path back down.
Yeah, they called it yo-yo despin. Someone slowed down the footage on my own video and showed me that it actually like shot out two things to decelerate or whatever.
Interesting. So I'm guessing they figured out the yo-yo for certain things to circulate. Like, you know what I mean? Like you're putting something in one of these fucking ether streams.
Well, my thing about that was like, if you're trying to set the record of the highest, why would you slow it down? But whatever.
There's also there's jet streams as well, right? Like, so if you actually look into it, the jet streams, what they would have you believe is like, oh, since the Earth spins, it's a ball that's spinning, then the weather tends west to east. But in reality, it does not do that. It actually changes at different altitudes, and there are counter rotations. The jet streams go opposite directions at different layers.
Right.
And who's to know exactly how fast even the air is going?
Bob wins, right? Bob wins. Alan's the man. He's thinking, doing what I'm thinking.
Now get into what is it that everyone thinks proves that there are satellites up there in a vacuum, like
Wait, what am I looking
radio.
at right now? Wait a second.
Winds on
the wind
flat
patterns
Earth.
on a flat Earth. So it's radio transmissions, bro. It's just radio signals.
And the height is pascals, like different pressure.
Yeah, that's what. Yeah,
different altitudes. Yeah,
different altitudes. Okay.
As if an ether vortex, right? So
this is
faster the
tight.
further you go out radially, right? Isn't that what we were
This is
discussing
really cool.
in a
Who made
hypothetical model? Well, this is actual winds. This is
the
actual
wind
wind.
data. Yeah. Pop the magnetic flux on there.
It's like his favorite.
Yeah, bro. Now holler at me, bro.
No. Okay.
Now turn it into a globe real quick.
Nah.
Watch how stupid it looks. Yeah, watch.
Hold on. Do you guys want to see conic equidistant or whatever?
Now look at the bottom.
Can you please
There's
send
the
me
north.
that?
Looks cool.
Bobwins.com, man.
I got you. I got you, Elson. Bobwins.com. I'll give it to you.
Oh, for sure.
Easy to remember, guys.
This is what I come here for. This shit. New shit. I love learning. I love seeing new things like this.
Go down in the height a little bit.
We've used this for many things.
Go down on what?
We love
go down in the height.
Who made this?
Yeah, so it gets
now it's more pronounced now.
Oh yeah, there we go.
And it's so the funny thing is if you compare that magnetic counterspatial South Pole to where, like, say, the magnetic declination maps put the South Pole, they're at completely different sides of the world.
Look at that, bro.
Wow. What do you think about that, Robert? Just curious.
The magnetic pattern?
Yeah.
To say like an ether vortex. Yeah.
Well,
what
were you saying about the bottom, Shane? What were you saying about it not working with the ball shape? Yeah.
Hold on a second, bro. Robert was about to answer.
He was in the middle of talking, dude.
Yeah.
Pardon me.
It's all good, bro. Just go ahead, Robert.
All right, we're looking at a two-dimensional projection of what could be a three-dimensional space, right?
Mm-hmm.
Yeah, it is true.
Okay, that we live in a three-dimensional world, at least on the surface we do, right? So that shows me, the one you had before, shows me the aura, or the appearance of something that is on a flat surface. The pink stuff is on a green surface, and both of them are two-dimensional. But that's because of the picture.
Well, this would just be a top-down view of it, basically, right? So it's just got the measurement of the magnetic flux at different altitudes, and then it just creates the visualization as the top-down view. And if you go to the globe, it actually looks pretty coherent in the north. When you zoom in and you start going down around the equator and further south, it just, I don't even know what's going on.
Yeah, it gets.
But how can you rotate a flat surface in 3 dimensions when it's
Oh.
only 2 dimensions?
Look at the south patterns, though.
Oh my God.
It's so.
The surface, it's just the magnetic flux over top of the Earth, right? And it goes right with the ether drifts measured. So this I guess the real question here is you'd want to go to the south and see what the ether tests do there.
Right.
Because the most prominent ones are from like Russia usually, which is even further north, right? So yeah, I don't know, but all I'm saying is, as to can something move over top of the Earth, I certainly think so. I don't think it has to be free falling around a ball in a vacuum by any means.
But like, it goes faster the further you go out, right? And then what we're talking about, what we said it would have to do.
It would, yes. So like the real crux of the issue here is go to the equator, and on a sphere, for example, the pendulum should not be precessing at all. Right? And then you should keep going south and then you should do all these tests. You should do Michels-Morley, do the pendulums. You should do all the tests out south. Which, by the way, they basically don't exist. So, I'm not. Anyway, that's the fundamental difference. There's a giant overlap here with the globe and the flat Earth in the north.
Yeah, we just went over coordinate systems for like 2.5 hours, so we understand that flipping between both of these coordinate systems isn't the thing, right? It's which one does the data make more sense when visualized on.
Right, that's the question, Robert.
Yeah, we're not talking 2 dimensions versus 3 dimensions. It's still 3-dimensional, even over a flat Earth.
Well, yeah, it increases with altitude. Yeah.
You're asking which one makes more sense for a representation of the magnetic flux around the Earth, right?
Sure.
Sure. Yeah.
Okay. Well, I can't make any sense out of it. All I see is red and green.
Yeah, fair
I
enough.
don't. I
The
don't see
magnetic
the.
flux is higher with the red, so the red just depicts like a higher magnetic flux, and the green is towards the lower end of the spectrum. The blue is the lowest. And the part where all of a sudden it gets blue is conveniently that part where we can't actually go out there. Yeah, see that little blue spot right there, randomly on the bottom of the globe there? Like, you can't go there. That's right where the 60th south latitude hits. So, your guess is as good
I
as
don't
mine.
understand. Why can't you get to the 60th latitude?
As soon as you get to the 60th south latitude, you're within the Antarctic Treaty regulations.
You get turned around, you
Oh,
get
I
sent
see.
back.
And the
They have
Arctic
a warning
Treaty, if you
system.
go
They have,
north. Yeah.
All right. So you're saying there's legal restrictions, not physical
Democratic.
oh,
restrictions.
there's
Yeah,
pseudo
legal
legal.
ones, yeah.
Come on.
And they're also at the north as well. It's called the Northern Warning System. There's a trip line at 55 degrees north latitude.
They literally have it ringed out where if you go past a certain threshold, they'll know, and if you physically go past a certain threshold, they'll stop you.
Yeah.
Right.
And that you don't get due process in America.
Right.
I actually worked on that. It's called the dew line. It's the radar.
Wow.
Wow.
Steve worked on it? No way.
Robert, you're gonna be
Yeah.
a great ally in the future, bro.
Yeah, that's right. It's called
Around
the dew line. I want to hear about it. You worked on it. What did you do?
Well, in a back office sense, but the purpose of the dew line was to detect any Russian missiles that are coming over the poles, and I guess that requires an explanation of going over the poles. But in any event, that was the purpose of the dew line. It's a set of radar stations that were remotely maintained. Did you know that? They only went there
Interesting.
every
Like,
6 months. They sent a helicopter, and in some cases it was unmanned, and it just had it plugged in and restored whatever was needed to the station and left.
but like you said, it's a
So they had the,
radar.
yeah,
Like so, but that
dew line,
detects. Yeah, you said it detects. You said it was for all the bad Russian missiles, but like as a radar, say it could detect, say, other things that move up there, right? Like boats, people, cars, vehicles, things, right?
of
Yeah.
course.
Yeah, it's
Okay.
called the Distant Early Warning System. I think it was created in like 57. It's the same year they literally 45 they brought the Nazis over here in paperclip, and they were obsessed with Antarctica. Then all of a sudden our government becomes obsessed with Antarctica in 1946. Operation High Jump. We go explore there for a little bit, we come back. Then we do Operation Deep Freeze, we go back to Antarctica, then we come back. And then we do something called the International Geophysical Year, where we cooperated with 40 countries internationally to agree to basically monitor the northern and the southern portions of the Earth, the North and South Pole areas, 55 degrees north latitude, 60 degrees south latitude, for scientific purposes. That was 1957 through 58. At that same year, that's when they founded the Distant Early Warning System, the DEW system. And then I think in 1988 they updated that to NWS, which is the Northern Warning System. So it's the same system, just updated. And now, our military actually has like an Air Force base in Thule, for example, and like much further north.
Greenland.
Yeah,
All those suspicious things, but like wouldn't you think it'd be possible that they could ostensibly give you one reason for the installation of the new system, but in reality use it for something else?
Oh, you mean the radar?
Yeah, I'm
Yeah.
still stuck on it.
I don't know how you could use the dew line for offense.
Oh, I think it's defense. I
Offense.
think
No,
it's
no.
it's
Yeah.
monitoring. It's just monitoring activity. Like,
But like say instead of a military, civilian.
Now, one part of the puzzle that isn't filled, though, is in this idea that we're proposing here, Russia would have to have been doing the same thing. So Russia would have had to basically extend the line.
Yep.
Which, I mean,
Yeah,
I
they
don't know
have-
why they wouldn't have. Yeah.
They've been allies forever.
Well, that's a rabbit hole. Yeah. Are we actually enemies with?
Countries.
Yeah, 40-year Cold War.
Cold War, quote unquote, cold. It's almost
But,
like just a distraction. Like, hey, we got a head start on exploring all this shit, while you countries think we're about to kill each other with nukes. Like, and they just joined forces and explored the Antarctic and the Arctic.
Join
Yeah, they
hands
definitely
in
all agreed on that part.
celebration and peace for the one thing that they can agree on for some reason is
Right.
space in Antarctica. It's fine.
Yeah, no worries.
I'm interested about the idea of them shooting missiles over. Or rockets.
Well, wasn't Hitler supposed to have had a base in Antarctica?
Oh yeah,
Well,
he did.
Definitely another
Not-
couple rabbit holes there.
Yes, he did. He also went to Argentina. You can still go to South America now and there's like all these like German towns.
Yeah.
Hmm.
Yeah, if
Yeah.
you look at Tim Kennedy's Hunting Hitler, yeah, he was on Joe Rogan. You can watch that.
Yeah,
Talks
and there's
about
declassified CIA documents that literally say Hitler escaped to South America.
yeah.
The CIA was tracking him like years later. Yeah. But that's another rabbit hole. It's just
Another
what's
rabbit
interesting
hole.
about the whole thing is they were obsessed with Antarctica, and then when we brought them over here, we became obsessed with Antarctica. Like the very next year, right? Like,
Right.
yeah, it's pretty interesting.
And space.
Space afterwards. Yeah.
Slightly
Yeah, we
after.
founded NASA and signed the Antarctic Treaty within a year of each other. Yeah.
Yep. Isn't that like a super interesting comparison? Like right after the like, hey, look over here, look over here, don't look over there.
Yeah.
Well, did you know they actually founded NASA the same year that document about the firmament was drafted?
Interesting.
Yeah. So
NASA-
whatever they were doing, they were
NASA
up to a lot.
NASA was founded after first Russian satellite went up, Sputnik.
Yeah, 58,
and
I
that
think.
was
58.
Yeah, that was the challenge to America to try and catch up with Russia, and that led to the tremendous technical project to put a man on the moon by 1970.
Well, that's the
Yeah.
story anyway. Yeah.
Yep, and then one of the astronauts said, "Oh, we can't go there next year. We can't even talk to each other in our own buildings or get to low Earth orbit." And then he died. And then they made it. Just take them out. We're good to go, fellas. No, yeah, it's interesting, man. I will say what's really interesting is when you start to look at the declassified documents, it seems like our government was cooperating with Russia with a lot of scientific endeavors. So that seems counterintuitive, right? I mean, if they're my enemy and we're basically in a technological space war, why would I be working with them scientifically and technologically when the whole idea is like, well, we got to make sure we're more advanced than they are, right? And then it serves both countries very well because they tell their population, we were the first one to send a satellite to space. We're the first one to send an animal to space. We're the first one to do, basically all primary space exploration. And then America gets to tell their people, we're the first one to land on the moon. So we won. And so both countries just get to tell their people they won. So
Most scientists are not political, too. So the Russians and American scientists were very copacetic and didn't really play politics. And look how fast the International Space Station got put up and the joint activities. So
wow.
I thought that Russia would have complained if we claimed that we landed on the moon and we didn't. But then I learned that the Russian scientists were very much sympathetic to America, even though politically they were opposed. And so that reasoning that I had disappeared. So right now I'm in the middle somewhere about landing on the moon.
yeah, you're good, brother. It's a rabbit hole. I will say that's what I first thought when I heard about it. I'm like, Russia would have blown the lid on this.
Exactly.
And yeah, but like what's interesting though is there's actually some Soviet astronauts who have come out and said that no one's ever been to space. You can't go to space and the Earth is flat. A literal Soviet astronaut. There's actually 2 Soviet cosmonauts have said that we've never been to space, but
Polish guy too.
for sure, for them to have faked it, it requires cooperation from Russia. There's no doubt about it. Like some type of cooperation at the higher levels, right? Like, I don't think that, I think 99.999% of the Russian intel or government or military would have no idea. As far as they're concerned, we did go, right? But there was actually a lot of newspaper articles at the time saying that America's lying. They didn't actually go in Russia.
Also to think about is the financial aspect of exploring the extremities of Earth, right, and space, right, the extremities of where we can go. You justify all these expenses, right, and then now you also have war, right, war to justify, like, oh, we're actually enemies. So you have all these weapons contractors, etc., and now they've like combined forces with Space Force. Now we'll have never-ending wars in space. This is how we can justify all of this. All of the spending.
The war was 40 years long, bro. I mean, you know, that's a long time to kind of justify consistent funding. Something else that's interesting, the last thing I'll say here, but like, we've actually had, there's films that have been declassified now that were from Russia that showed that they were faking space propaganda to their public. It's actually been proven. They were using little models. They were filming models, and then they were showing the films to their population as if they were going to space. So there are actual videos, you can watch them like they're using models, little handheld models with like, you know, terra firma replications and then small lighting systems, and they're just like faking satellites and rockets and stuff with little models. So it begs the question, of course, why would they have to do that, huh?
Were there not examples of that in NASA videos as well, with the shuttle releasing satellites, where you could see the gentleman actually in the background?
Yeah. Yep.
And also the string attached to the satellite as it spins up.
Well, and actually Germany did the same thing. Werner von Braun, they you know, it's just openly known as well that they were lying about what they could do with rockets to the German people. You know, Werner von Braun, they were claiming the rockets could go higher than they really could, and blah blah blah. They were showing them older films when the rockets would blow up. They would tell them they were successful, and so it's pretty interesting. But yeah.
But yeah, it's just
But wait,
obvious.
I thought Bennett was firmly with the moon landing and the space race propaganda. You said you're doubting it. You said he was in the middle now. That's very respectable. Oh, that's where he's been the whole time. Oh, okay.
Well, that's what I knew. Yeah. I mean, dude, you gotta admit, dude, that is a rabbit hole, bro. I don't think someone just like wakes up and they're like, I know what happened.
The last 20 minutes of conversation are actually like 13 different rabbit holes. So
pretty much.
Yeah.
Yeah, and like 13 years of research.
Yeah. I mean, even when I first was looking into all of this information, you know, I always thought that NASA was fake the footage, but they still went to the moon. It took a long time afterwards to realize, oh no, they never went to the moon.
Oh, that doesn't make sense to me. I thought so I was actually 13 when I found out the moon landing was fake, but I thought that they faked it because of the issues with Russia, meaning like they wanted to show like technological superiority to the world.
Right.
And so they lied about going to the moon to basically placate the Russian threat. So that's what I believed.
Same kind of thing.
But then I found out they work together.
Anomalies. Yeah. I was always thinking about, oh wait, what about these moon anomalies? Oh, the moon's actually a spaceship, and I went into that that kind of stuff. But yeah, it's rabbit holes upon rabbit holes. So
I guess it is the big red pill, right? Is if the Earth is flat, then the heads of state of all these countries are kind of cooperating, right? I mean, they have to be.
Right. It's kind of like you can see through the magic show.
Well, they clearly are, right? Because for the last 2 years, the whole pandemic unfolded, and everyone acted in lockstep. Countries that don't actually coordinate have all followed the same plan systematically right in front of everyone's eyes. Everyone went through the same thing there, right?
That's crazy.
Yeah, it's funny you say lockstep, right?
Mm-hmm.
Since that's the actual name of the document from the Rockefellers in 2012 that literally outlined the whole thing.
Of course, that's the word that I use. Yeah.
Yeah, the world shut down overnight in unison.
Right. So it's not like all the governments would like collude on anything bigger than us to not our best interests or anything, right, guys?
No, they signed the Antarctic Treaty because they care about the penguins, bro.
Dude, it's for research and science.
Dude, that's the thing that's so like convincing for me anyway. It's just you follow the political timeline. You know, NASA formed, all these different operations, Operation High Jump and Deep Freeze, and then you got these high altitude bombs like testing the physicality of the firmament because it's like they've reached somewhere. I don't know. I'm of the idea that the reason why they're overbearing their control, like they're really showing the population like we have to control every aspect of society, is because there probably isn't anything else past the 60th like a certain spot. I feel like there is a limit. Like I don't know if there is.
Yeah, I'm sure there is, but I mean, who knows what it is, right? Like they definitely, one thing's for sure, they got super obsessed with exploring the Earth and the sky, and then they created the CIA
Control.
and the
Yeah.
NSA and the DIA
Right
and the
after.
NASA. Yeah.
Which is just, you just follow the dots like that, and it's like, either A, they want a really, really big head start, or B, they're figuring out like the limitations like to a T.
Well,
And it's
people
like
have fought to the death for one thing throughout all of history, and that's
power.
land. Well, yeah, land and power.
Yeah. Omniscience is what they want.
So, do we have any more questions for Robert Bennett while he's here? We've been going on
Oh,
for quite a
sorry,
while.
Robert. My bad.
Oh. Any questions?
Do we? People
Any
showing
answers?
up.
Yeah, what's your take on gravity?
Okay. From the Hildegard point of view, which the book you just had up on the screen, the universe is filled like a balloon with ether under high pressure, and I have some proof of that. The Atosowski chart shows that the measurement of their ether was enormously high pressure. So the model for Hildegard, as far as the pressure of the ether, is it's enormously large and it fills the entire universe. But then there's a problem. We know that the force of gravity on the surface of planets of mass varies with the inverse square law, and it's different on each planet's surface, but it would have to be constant if they had the if you use the Hildegard model. Well, we have bound ether inside mass. That's what it basically is. And all of those masses that we know of, all of the particles that have been studied have spin. If ether spins, then it has a centrifugal force on its components. That means that the ether moves away from the center. So imagine one atom on Earth out of all of the enormous number of atoms. It consists of rotating ether, which pushes away the ether from the center, creating a drop in pressure. Now, that's, of course, minuscule. That is only infinitesimal size. But if you add up all of the pressure drops from all of the atoms and all of the electrons and all of the spinning objects at the atomic level, and you get something that would cause a drop in pressure, causing the outside pressure to be greater than the inside, which means you have a inward force towards the center of the Earth. And that's what we call gravity. So I'm saying the motion of the spin of the ether atoms creates a pressure drop, and that pressure drop is less than the outside. So the outside tries to push in, which is what gravity is. Now, why is it an inverse square law? That is still to be done, TBD. Okay, but that's what my version is of what gravity is. It's caused by the motion of the atoms plus the universal pressure of the outside atmosphere, ethosphere, which is constant throughout the universe. So that's it.
Okay, nice. Hey, Alan, do you think you could send him that paper, The Electromagnetic Nature of Gravity? I'll drop it in the
Yes,
Discord.
sure can.
Yeah, no rush on that. If you ever get time, you want to check it out, you might find it kind of interesting. This dude is a dissident, of course.
Robert, I highly recommend watching that that documentary on Isaac Newton, The Dark Heretic. If you haven't, highly recommend it. I'm still trying to
Okay.
find. Yeah, I'm still trying
What
to find.
channel on it?
I'm gonna send you the link. I got you. It's on YouTube.
You have my email?
Oh, just on Discord.
Oh, all right. Alan will have to show me how to do that then.
I can send it to
Yep.
Alan to send you if you'd like.
Yeah, to the
Yep,
left,
alright.
there's
Don't worry about it. It's fine.
yeah.
Don't worry about it. We'll get to it later, bro. It's all good.
For sure. I'm still trying to find that vegetation on metals or vegetation of metals. If anyone can find that unpublished manuscript from Isaac Newton from his journals, please let me know. I'm looking for that forever.
What are you talking about?
He apparently had this unpublished secret manuscript called "The Vegetation of Metals," where he says that the
Sounds like an alchemist type thing. Wait a second.
It
Wait
is.
a second.
It literally is. Yeah. It's his alchemical view of the universe, where he talks about the Earth being like a living being, drawing in ethereal breath and transpiring gross matter, and that
What? This dude hijacked my model? I'm just
I
kidding.
swear, but like, when you were talking about it, I'm like, dude, this sounds exactly like the vegetation of metals from Isaac Newton. I'm trying to find this, where he talks about ethereal breath being the cause of gravity. So
Yeah, I've never heard of that. That's very interesting.
Yeah, it's like the metaphysical way to explain the physical. That's kind of cool.
Yeah, can you stick more on that?
It's just here, I'm just gonna resend. Here, I gotta find it again.
Yeah, maybe in a bit.
Yeah, go ahead.
Well, anyone else got some more questions?
I like that.
Yeah, so I got one. So we know there's a preferred direction east to west for the propagation of electromagnetic waves. But what are your thoughts on the Pound-Repka and Pound-Snyder experiments showing that there's also a preferred direction for down? Because basically what they said was they couldn't determine if the photon, that they were measuring, as if it had acquired a gravitational acceleration of 8.9 meters per second squared, and that's what produced the frequency shift, like as if its acceleration increased, or if it was due to the gravitational field of Earth, so-called, manipulating the wavelength.
Yeah, well, at different levels, the gravitational energy changes. If the gravitational force changes, so does the gravitational energy. And so what was it done at the Harvard Tower? The light beam was sent from up the top of the tower down, and that caused a redshift, and that was considered confirmation of that's one of the proofs that's given for general relativity. The Pound-Repka.
Yeah, they try and swoop it up, but in the actual papers, they say that they can't determine any relativistic effects out of their experiment. And actually, I'll just read it here real quick.
Wait, so you're saying that not only is there's only a preferred direction, which is uniform, but there's also a uniform down, meaning that this tangentially inward nonsense on a sphere doesn't hold water? Is that what you mean? What a great question.
Yeah. So look at this. Look at their 1 second. So this is what they say. And their first paper was titled on the apparent weight of a photon, and like they were saying, like, hey, we're making no claims about the confirmation of relativistic effects here. What we're seeing is either the light moved faster, as if it fell, as if it was as if it were an object that gained weight, or that its weight caused a acceleration to the ground or whatever, and then or if it was due to the gravitational effects of uh, from the gravitational field in the Einsteinian sense. So yeah, they said it should be noted that no strictly relativistic concepts are involved here, and the description of the photon or of the description of the effect as an apparent weight of a photon is suggestive. The velocity difference is predicted is identical to that of a material object that would acquire in free fall for equal time of flight. And then here at the end, towards the end of their paper, they say the view of the local time scale depends on the gravitational potentials, appears to require a more coherent source for confirmation. This present experiment is unable to distinguish between frequency change and velocity changes, for example. So I'm taking that as like there's also a downward bias, so like light's actually, the electromagnetic propagation goes faster when it's going down. That's my interpretation of what I read.
Yeah, that actually makes sense though, right? If you look at static electricity being the ether under stress or strain, so there's an energy source above us radiating down, which creates that like electrostatic bond that holds all matter itself together, and that gives us the downward current, right? Which gives us the downward bias. Then if
Yep.
light is the ether and there is that stress or strain through the ether, like Tesla said, static electricity being the ether under stress or strain, then there actually logically would be a slight bias of the propagation rate of light down, which sounds like a very interesting thing that can be tested.
Yeah, I just used it for a new argument to obliterate upward acceleration or whatever they say. So hopefully that turns out well.
Those rising upward earthers coming back at you.
Yeah, dog. So
Yeah, that's fire, bro.
Yeah, this is great. This has been great. This has been a whole night of
Totally
fire.
forgot about that, bro. You told me about this. You told me that there was a vertical, like directional preference.
yeah, I was
Oh.
well when I told you about it, I was like early on in the conception of it, and I wasn't super confident in it. But it's been in the back of my mind for like a while now, and I can't stop thinking about it. And it just came up today with some dude in your Telegram chat, so I made a quick video on it, and I feel super confident in my interpretation now. Like, there's no way there's not a downward bias for the light. And then so like we have etheric pressure measured in the atmosphere or whatever, right? So that was 1.3 minus 10 to the 36. So it's like we have a ton of pressure. Like how is there not a downward bias, just in terms of that? So I'm
Yo,
pretty
that's Sam.
sure.
That's like seems super testable, bro. What
Yeah,
what is the differential?
you're a differential.
I was just asking what the difference. By the way, guys, thank me later, but I made a meme. So, yeah, okay, yeah, like we won't take over. I'm supposed to be streaming actually in a second, but
Oh shoot.
is your understanding kind of like overlapping with mine there? That like that, yeah, basically that the downward pressure radiating from this energy sources above us creates the downward etheric pressure, giving
Oh
you
yeah.
giving you the ether under strain, which creates static electricity.
Yep.
Therefore,
So
one
with
could say the energy presence above us is quite literally holding the world together.
yes. Dude,
It's
that's what I've
almost
been
like it's the
thinking. So
creator.
so you know how so you always say like, static electricity and all that is the ether under stress and torsion and all that stuff. So I was like, okay, cool, it makes sense, but I didn't really get it or whatever. But I started recently looking into the electron, JJ Thomson, and dielectricity. And
The
then
corpuscle, you mean?
yeah,
Oh,
it's like
man.
like all the things that would help make it make sense. And
Yeah.
it's like, oh yeah, okay. So it makes sense now. Like, wait, yeah, I'm on board, dude. So
Very cool.
That
I
is
just can't believe I never thought about that. I'll pay you later, bro. I'll put you on the payroll
oh yeah.
as soon as I get paid.
Nice.
The very first time.
Let me scroll through here.
This has been a
if I
super
have
chill,
something.
like back and
Robert,
forth.
do you
Though.
Robert, do you
Thank
think
for
that
your
matter is
information,
actually
Robert.
contracting and we just can't tell?
What evidence? Do you mean like the length contraction of relativity or something else?
Yeah, that's what I meant. Yeah,
Length contraction?
Okay.
No. Never observed.
yeah, of course. It's just hijacked from Oliver Heaviside's observation of the electrical contraction.
Yeah. So the unipolar dynamo is a good one, and so like the predictions um, that relativity theory makes, and what's the other one? I can't remember, but it was the lab frame again standing out as the only frame that could correctly here it is, that can correctly interpret what's happening with this electric current generation. So if you
Right.
want to go over that real quick, I think that's a really good one.
Well, what's on the screen is a visual of the lab experiment. At the bottom is a motor that drives the vertical axle, and there's a copper disc on top, which is the conductor. Beneath that, you see the black metal, which is the iron magnet. Yep, right. And those can be independently connected to the axle. So you can make both of them rotate. You can make one of them or the other one or both of them at rest. Okay, so you can control the motion. On the top, you see a brush that is connected to the conductor, and that kicks off the voltage if any is produced. And then off screen is an oscilloscope which shows you not only the magnitude of any EMF or voltage that's produced, it also shows the direction. So if anything is reversed in direction, it'll appear on the diagram. Now, the bottom line to all of this, there's the full setup. If you do all of the different combinations of disk moving and, conductor moving and magnet not, and vice versa, and so on, what you find is that there are two violations of the law of relativity. Faraday's law says that the voltage will be produced if there's a relative voltage between the conductor and the magnet, right? The conductor and the magnet. Well, there's two situations in which that's not true. If both the conductor and the magnet rotate, then the law of relativity would say there's no relative motion, so there should be no EMF. That's wrong. There is an EMF detected. Another situation is when, let's see, the rotates and the magnet. Well, I forget what the other one is, but it's in the slide notes. So there's two situations where the it's line 6 and line 3 on that chart. Those are the two examples where the law of relativity doesn't apply. And yet they all pretend today, when they study electromagnetism, as though Faraday's law works. The only way it works is the way you would expect. The conductor must move relative to the earth, to the lab frame. If you make that change, then all of the results agree with Faraday's law. This proves that electromagnetism is just as valid as mechanics in saying that the lab frame must be used in order to obey the laws of physics. So we have a unity between electromagnetism and mechanics. They both say lab frame must be used to predict the laws of physics, whether it's a magnetism and electricity, even other field theories like quantum field theory. All of those still depend on using the lab frame in order to correctly predict the results. This is called consistency.
Yeah, it's called limitless corroboration. Endless independent corroboration.
It also points to a spiritual problem, as I pointed out, because why is the Earth the preferred absolute frame of Newton? Why are we pointed out as being the only place where the laws of physics are obeyed? If you're in any other frame of reference, you can't use the laws of physics.
That's so funny because that plays right into their like philosophical, non-science based fear of Earth at the center of everything and the Copernican principle and like the literally like this the decisive choice to move from into philosophical grounds to not pursue things based on Earth being the center and us having a special place in the universe or whatever.
Well, this, I mean, it has this very serious philosophical implications, like you just said, right? So, like, we have natural laws and we have laws of physics, and we apply them here in this natural world or material world. And if only this stationary lab frame is where these laws of physics are applicable, then it denotes something supernatural required, like supernatural law required to make sense of what's happening outside of the lab frame. Right, like by definition, something that isn't limited to the natural.
Imagine that, dude. Just by saying that, everyone knows the importance of the lab frame. We have endless corroboration of the importance of the lab frame, and Einstein came along and made it doesn't matter, insignificant. Every
Everything's
reference
relative.
frame is equal and relative. Doesn't matter. Therefore, nothing matters. Gone.
Yeah, say what you want to, but that man's one hell of a wizard, man.
Yeah, dude.
Use the lab frame for everything that you do, but trust me, the lab frame isn't real.
Dude, right?
I mean, yeah, it's just to hide God. It really is. To hide that you're special, to hide that there's a creator. It's just
Yep, and that you're gonna go back to the source. Better get your act together.
exactly.
Amen.
Exactly.
You know,
But
it's like the math, the math world. Suppose you were on Earth and you said, okay, I measure and I find 2 + 2 = 4. If I go somewhere else in another frame of reference, do I still expect 2 + 2 to be equal to 4? Yes. And so the assumption of Newton and all the others with him was, okay, the laws of physics I know are valid on Earth, so they must be valid everywhere. Well, that requires the scientific method to be tested, and that's what they left out. Newton did it with his bucket experiment, but nobody interpreted that correctly. They all interpreted as Mach did, as the influence of the stars, or Newton himself said it's absolute space, but he didn't tell us where absolute space is. So if you use the analogy with math, namely, if you know something is true Earth, does it necessarily have to be true when you're off the Earth in another frame? So the assumption based on math was that, yes, of course, 2 + 2 = 4 everywhere in the universe. Yeah, but Newton's laws and Maxwell's laws only are obeyed in the lab frame. If you're anywhere else in any other frame of reference, they don't. So that's the surprise. Based on their math reasoning, they would say, yeah, everything's the same. Everything's 2 + 2 = 4 everywhere. And that's true for math, but not for physics. That's what we find if we obey what the experiments tell us.
Damn. What a nice cap to like the best Aether Cosmology roundtable that I've ever been in. That was a good.
Well, thank you so much for coming in and imparting so much wisdom and knowledge, brother.
yes, thank you.
Yeah, thank you. That was great. I really appreciate you coming down and having a nice chat with us, a nice long chat. Everyone was respectful, so thank you everyone else for that too.
Yeah, well, thanks for inviting me. Austin, I have 2 comments. I noticed that you've put up a 10-minute animation about a day or 2 ago. Nice quality. What I'd like to
The
do
Toby's
is
clip?
say it again.
Is he talking about the video that you put up, that Toby clip? Nice.
Yeah, that's a nicely done quality. What I propose is that if you need any help with research, I know that you do a lot. I see that in the results that you get in your videos. Really amazing how you can spit those out quality in the short time available. So if you're interested in any help with research in an area that we both are interested in, let me know. The other thing is, you mentioned PayPal as one of your payment methods. I can't go with PayPal because they promote abortion. But if we can work out another payment method that I have, then I'd be willing to talk about it.
Respect.
You look at your emails.
All right, thank you so much for the kind words and the sentiment, brother. I'll check my the Proton mail.
I think it's Gmail.
Okay, with yeah, okay, cool. I'll check my email for sure, and then we'll stay in touch that way.
Yeah, okay. Because the payment methods that you list, I don't use.
Oh, you're making me want to get rid of PayPal now.
Right, dude, I respected that immediately. I don't care about PayPal, but he's like, nah, they like to kill babies, so I don't want to give them money. I'm like, well, I respect that guy.
Yeah, I'll have to try to create something else. They've actually kicked me off of there one time anyway.
Yeah, that's
So
not safe. It's not
there's
safe
a
there.
site called Zelle that he uses that I was going to register on. I'll send you that.
Careful with Zelle. I'll tell you later.
Yeah, I've been Zelled before, bro. I was, but you know, see what happens.
Okay, I'm gonna shut down, guys. Good to be with you.
Yep.
Hey,
Peace, bro. Thanks for coming
Thank
out.
you, Robert.
Come back
Thank you.
anytime we're here.
Alan, I'll
Come back
send
and
you an
chat.
email. Okay.
Yeah.
Bye
Hey,
now.
yeah, we'll see you next week for the Aziz and Unzicker review. We'll do the video live.
Okay, I'll send you an email.
You're the
All right,
star of the
peace.
show, Doctor.
All right, much love, brother. All right, guys, I actually have to go.